when we use everyday APIs for the data, Remix gives you write and read through what's called and what's been around for a couple of years, which is the HTML forms. So by leveraging forms and JavaScript, Remix can do what is called to be progressive enhancement. And by doing this, it also gives you a better user experience in like different ways. For instance, you don't need to download and evaluate JavaScript and CSS assets when you're including JavaScript with Remix, and it will only fetch data for the parts of layout that change whenever you're changing places. Finally, it doesn't over-abstract the underlying technologies. What I mean by this is, the team that created Remix, Ryan Florence, Michael Jackson, they work for React training. And as they've been working throughout these years and teaching people, they found out that most of the stuff are overly abstracted. Remix abstracts some things, but the things that are abstracted, they give you to learn them the same way you use the browser. So you have an abstraction, but the abstraction is controlled so that you can learn stuff as previously. So, fundamentals of Remix. And now it's the part that we're going to get practical, and I'm trying to share some code. So Remix, for me, it's about three different things. The first one is the concept of nested routing. So nested routing is pretty much the general idea that you have coupling of segments of the URL that have a component hierarchy in the UI. So what do I mean by this? So let's look at both of these examples. We have user profile and we have user account. These are both routes. So considering the route user, it has either a profile and it has an account. One thing that we can see that it's common between these two routes, it's this top level part. So this represents one part of the hierarchy. When we speak about nested routes is, instead of when we want to go to user profile or user account, creating a main component to this, we can just leverage nested routing and render whatever we need inside of our parent. Don't worry, I'll show you a bit more when we get to the code about this. So, speaking about data loading or mutations. Before Remix and considering a React ecosystem, we were used to these kind of things, useEffect, React query, SWR. With Remix, we don't have to worry about this type of things. By including something that it's called a loader, this example is not very well seen here, but by having something that it's called a loader, this is a function that will run on the server, and Remix will use it to fetch your data, and then render your component so that when the client receives the component, it already has the data. So it here, once again, removes the need for doing client-side fetching. For the mutations, it's pretty much the same thing. So, like I said, mutations in Remix leverage forms. So how does it work? Pretty much we just describe our form as we have. You've been using before Remix and traditionally with a web. And then we do something that it's called an action. An action is something that runs on the server, and it will pick up when data is transmitted through it so that it can perform your mutations. So now considering this, I'm just going to share my screen and my code. Okay, I need to change this to the light side. Let me see. Okay, better? Cool. So, let me just show you my example in here. If this wants to change, so. Okay. Okay, so here we're going to have a simple application, and the purpose of this application is to build something like the Tower of Babylon, which was something that happened in older comics of around 2000, where we had pretty much Batman build a list of the weaknesses of every member of the Justice League. So this is pretty much the purpose that I want this application to serve is we are going to be adding a way to check all the superheroes that we have in here, a way to add new superheroes, and a way to delete them. So this is pretty much the behavior that we're going to want to do in this application. So right now, what we have in here, the login is already pre-built, so we don't have to worry about this kind of stuff. But what we have in here is a nav bar where we want to list our nav items. So this will be the first step that we want to do in our application. So here we have our heroes route. How do we know that this is a route? Because it's inside the routes folder. Pretty much what happens here is that Remix will look into this folder and say anything from inside here is going to be rendered on this route. So as this is called heroes, this is going to be rendered at the heroes route. So what we want to do right now is to find a way to get our data. So how do we do this? By using a loader. So loaders, we just declare them by importing a loader. We are using TypeScript, so I'm just gonna type stuff so it doesn't yell at me. Okay, so we declare our loader function. Then we're gonna have an asynchronous function because it's gonna do some data fetching. And now we're gonna use our models. So I have pretty much a bunch of models built here. This is using Prisma to connect with a SQLite database. But pretty much we have a bunch of functions in here responsible for getting our hero by your ID, for creating our hero, and to get our heroes and delete. So one thing that it's important to know is since we have an authentication built in this, every authenticated user is going to have their own built heroes. So this means that, like, for instance, like Batman is paranoid and he doesn't want anyone else to access the stuff that it has. If other hero uses this application or whatever, they're going to have their own data. So putting this in consideration, now we're going to get our heroes. And we're going to await and I'll call my function called getHeroes. So as you can see right now, this function needs a user ID. So the user ID is something that it's pre-built into the application. And the way to get our user ID, it's just called a function called requireUserID, and we need to pass it our request because the way that the system is built that whenever you authenticate, it creates a session storage for your user, and that is passed throughout all of your application. So for you to have access to that, the loader function gives you access to a bunch of stuff. It gives you access to your current request. It gives you access to parameters that your request might have. So here we just have a logic request and pass it this user ID function. And this, right now, we're going to have access to our user ID, so we can just pass it to our function. And now we have our hero list. Now the question is how we are going to pass this hero list fetched on a server to our client. Well, by using something called Json. I imported it from the wrong side. So what is JSON? You might ask. So Remix leverages the web, and here it leverages request and response headers. So JSON is a function that pretty much wraps your data with this response header. Response actually sends the 302 header, and it parses your data in JSON so that your client can have access to the data. So here we just send our JSON with our heroes. Oops, I mistyped this. Okay, so now that we are sending the data to our user, we need to somehow in our client consume it. So this is the scenario where we leverage something, a custom hook that Remix has built, which is called use loader data. This hook will be responsible for fetching the return of the loader and giving it to your client. So now we have a component here that's expecting our heroes list. We can just pass it. And if everything is well built, okay, this is, boom, it failed. Why? Oh, okay, because I'm sending the data and I need to send the heroes. And now if I refetch it, I should have my heroes here already listed. One thing that it's usually a common practice in Remix to make stuff with loaders easier is to type them out. So let's just create a type called loader data. And this will be used so that we can enforce that the data we are receiving actually matches the type that we want. So here we're going to be creating heroes, and we're going to say that this is awaited because it comes from our model, and this is a synchronous function. And the type is going to be the return type of our get heroes. And this will pretty much tell TypeScript that all the data that needs to be returned through here and through here it's going to be this one. And this will be able to enforce it and make sure that we have autocomplete and other kind of stuff that is cool from TypeScript. Um, so yeah, now we have our heroes, so we should be able to click them and show them. No, not really, because there's no way for us to show our heroes right now. This is giving us a 404 because it doesn't exist. So we need to figure out a way to display our heroes on the page. And right now, this is where we want to average nested routes. We have our main route in here, which is our heroes page, and we want to use all this empty white space in here to show our data. So let's create a nested route. First things first, before selecting our users, I would like just to have a default behavior. So whenever I pick up this page, I say, okay, no data is selected, please click add hero or whatever. So how does this work with Remix? Pretty much, okay, I already have built it here, but we create a page, a folder, with the name of the route that we are matching. So in this scenario, if the route we are matching is heroes, we want to create a folder with heroes, and inside of it, we're going to create an index. And this index is going to be just a default component, so default function, hero index, whatever. And what this is going to return pretty much is just a paragraph saying no heroes are listed, please click on the left to add them. So yeah, now that I have this default component, what we would expect for us to do it, okay, this is just breaking, was for it to show in here. But right now, we are not telling Remix that, hey, look, we have this and we want you to pick up the children, the nested routes, and render them inside of your main component in here. So how do we do this? Considering that these heroes is actually the main component, we have to let Remix know that we need to render nested routes. And how we do it? By adding an outlet. Okay, so if I go back here, you can see that automatically it added whatever we wanted. So pretty much an outlet will let Remix know that, hey, if you see something that matches this route, in this scenario, it's going to match our index. It's going to let them know, okay, this is a nested route, so I want to render it inside of this component. Okay, so just one thing. Oh, I don't have a default configurer. Okay, let's just change this really quick. So, okay, now we are listing our stuff, but we still have this issue that whenever we select a hero, we want to display it. Now, we want to use pretty much the same things as we did previous. We want to, whenever I select a hero, instead of having no heroes listed, I show the hero in here. So, how do I do this? Once again, it doesn't make a lot of sense to, considering that this route is an ID, I'm not going to be building a route for each one of these IDs. I have to Remix know somehow that, hey, we are going to have this route is going to change, so we need to figure out a way to display it. And this is where slugs come into play. So how do we represent a slug? We just do something like this. So yeah, I don't know if you can see pretty well, but pretty much this symbol will let Remix know that, okay, here, this is a slug, and this should match any pattern of text that is after my heroes route. So what this will tell Remix is everything that's in front of heroes should be matching with this slug. So now this is the part that we want to render our data. So let's just do this really quick. Okay, so in here, we want to display our hero data. Right now, I have a pre-built component in here that's pretty much just receives a hero, and it's going to return all the data that it has styled with Tailwind as well. So we're going to leverage this component just to render whatever we want. So we just here, we just send our div, then we put our hero creator, no, hero component actually. Right now it's failing to import. Why? Quick question. Hero component, hero component. Okay, we can just manually import it later. So right now, right now, since this hero component is going to be needing the data, we need to figure out some way to fetch our data through Remix. So once again, we're going to be leveraging our loaders. So we create a loader. Once again, typed with the loader function. I'm just going to fix this because this automatically picks up a server and we want node from here. And in here, once again, this is going to be an asynchronous function. And we want to pretty much follow the same approach as we did previously. So we want to get into our models and say to the database, yeah, can you give me any hero that matches the ID in my route? So first things first that we need to do is pretty much the same steps as before. We need to get our user ID. Oops. So here, this is an asynchronous function. Require user ID. Now that we have our user ID, we need to pass it the request. So once again, we leverage our loader function and destructure the patterns that we want from here. Okay. So we get our request and we pass it our request. Okay, so the next step would be to try to fetch our user. So here, our user or hero, sorry. So here we just call the function that comes from our models called get user by ID. No, user hero, sorry. Hero by ID. So this is a function that's supposed to receive a user ID and the ID of my route. So the ID that we see here, in here, it's supposed to be passed to our component. So how do we do this? Like I said previously, our loader function, besides giving you the request, it also gives you the parameters. So you can just leverage this and use these parameters so that we can have our hero ID. So here we just pass our user and we want to pass the ID. We just say parameters hero ID. So how does it know that it's hero ID? Because this is the name we gave after the slug. So it's going to be using it so that we can pick up the data that we want. Now you might be seeing that TypeScript is yelling at me. It's letting me know that this parameter is invalid. So we need to quiet TypeScript and letting them know, no, I'm pretty sure that whenever the data reaches there, it's going to be valid. So what we're going to be doing here is leveraging this function called invariant, which will pretty much assert that the data is not undefined. So this is going to receive our hero ID and the message, hero ID not found. So this is pretty much on the scenarios that for some reason the data is not valid and we need to list it. So this is just pretty much to assert it. And as you can see, TypeScript stayed quiet now because it knows that if it passes through this function, it's going to be able to display our data. So this is pretty great. Okay, so now that we have our hero, we should be able to return it. So once again, JSON. Let me just import it. And we're going to pass it our hero. One thing that we did previously that I forgot to do here is create our type for loader data. So here we're just going to create our loader data and with the hero and the type hero. Now one thing that you might see that's different from the previous one is the way we handle our heroes. Because on this scenario, I want it definitely to return our hero and not return a promise or some type of data that's undefined or whatever. So I want to make sure that my hero exists. So this is me actually enforcing that I want to use the hero type. Okay, so receives, oh, okay. It's referring to a type. I need to import this type from my hero. Okay, let me just fix this part from my hero server part. So wherever is it, it's hero server. That server. And right now, okay, first, oh, I need to put the models in here. Oh, wait, it's actually in here already. So I just need to get it from here. So here I have my type, and the type is going to be used here. Oh, I know why it's yelling at me. Because I had the same name as the component, show hero. So right now, I'm just going to enforce that I receive a hero, and I'm going to return it. So now that I typed, this TypeScript started to yell at me again because, okay, the return of your query can be null. It cannot find a hero. So once again, we need to make TypeScript not yell at us. So how do we do this? Once again, we just do some assertions. So we want to make sure that If there's no hero, we're gonna let the user know that something went wrong. So let's just throw a new response where the body is hero not found and the status code is gonna be 404. So that we know that, okay, if something went wrong, it's definitely going to let the user know. Okay, so now that we have our folder data and the data is being returned, we just have to figure out a way to display it. So once again, we average our data, use loader function, because it's the way that we can get the return of the data from the loader, and we type it as loader data. Okay, now I just need to redeclare my hero component. Hero creator, no, it's not the hero creator that I want the hero component from hero component. Okay, so this hero component is actually going to be receiving a hero, and we pass it through the data.hero. So now, if everything is wrong, if everything is okay, and we go back to this, and we refresh, now nested routes come into play once again. So pretty much picks up the ID, and it then, just recap, it goes into here, fetches our data, returns the data, and it shows us in here. If for some reason we pass it not a valid ID, it's going to throw that 404 response that we set up previously. So as you can see, nested routes are super powerful, because if I wanted just to set up another nested route, I could create the folder, or use the slugs, or use other name, whatever. So right now we are displaying our heroes. So we already taken care of data fetching. So how do we do mutations in the Remix ecosystem? Okay, this is the part that we're going to be taking care of. So let's create a new file called new. So the objective of this file is going to be a route that we want to redirect the user. So where it's going to have a form, because that's how we do mutations in Remix, and this form is going to be used to do a post. So how do we do this once again? Export, and we create our component, hero, create, add hero. I forgot the function. So in here, we're just going to be pretty much do what I said previously. We're going to create a form, and this is pretty much a standard web form, but Remix only added some extra functionalities in case we have JavaScript. For instance, as that examples that I mentioned earlier at the beginning of the talk, where it just fetches the data. It only fetches the data that it's going to be necessary in case of a re-render. So this is just for progressive enhancement stuff. On the other side, on the other aspect, it's going to run pretty much like a standard form. So we have the form, we specify the method that we're going to be doing. So we're going to be doing a post. And inside of here, we're going to leverage this component that it's pre-built already, which is called hero creator. Now you might be wondering, what does this component have? So first things first, it exports a type called action data with the things that this component is supposed to support. If it has a form error, if it has any type of errors, or if it receives some fields. Then it's going to be doing a couple of things. This is just progressive enhancement stuff with React, so it's pretty much just attaching refs to our inputs, and in case there's an error, it will focus them automatically. And then we have our labels, where the name. So each hero should have 3 attributes: name, weakness, and secret identity. And here we have our name, we have our input, we attach the ref that we created previously, we give it a name so that whenever we do a post, this is the attribute that goes into our form data. We give it a default value in case there's an error and we want to trigger a re-render. And we just use ARIA attributes in case there are errors and we want to let the browser take care of it. And we do pretty much the same thing for secret identity and weakness. And then we have a submit button. So this is pretty much the stuff that it's baked inside this component that it's going to be given to this form. So let me just give some new stuff in here, just so it looks prettier. Style, style, okay. And let's just add display flex in here. Flex, gap 8. This is just some standard stuff, so it looks pretty in here. Don't worry about this part. So in here, we have our flex direction, and we want a column. Oops. Okay, let me just format because on this laptop I don't have everything set up. So now we have the form created. We just have to somehow link this to there. So let's just add this part. So in our heroes component, we have to let the user know that whenever he clicks in here, we should be triggering this to the new route. So we do this by converting this div to a link, because link it's a component that React Router and Remix use, so that you can trigger a route change pretty much to the new one. So by using this component, we just have to let the Remix know where it's going to be the new route. So here we just say to, and the route is going to be new. Okay. Let's just format this once again. So now if I click in here, it's going to be sending me to the new component. In here, we have the form we created. This form has pretty much these attributes that we would like to create. Now, if we save, we still don't have a way to handle this post. So this is the part that we are going to be building now. Inside of our new component, we are going to be created an action, because loaders are for data fetching, actions are for mutations. So here, we create an action with the type action data, because that's what Remix gives you to. Oh, sorry, not action data, action function. Action data is going to be for later. So here we give this data node. And pretty much what this function does and the way it acts, it's the same way as the other one, as the loader. So it has access to the request, and it has access to the parameters if we need them. So in this scenario, okay, let me figure out what's missing here. Export const action, blah, 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 blah. Okay. Sorry? Anyone saying again? No. Okay, so, oh, this is the stuff here. No, wait, no, this is the stuff. Okay, there's gonna be something. Sorry? Oh, yeah, you're right. I didn't see the brackets. This here is very small. Thank you. Well caught. So now that we have our stuff in here, now we have to make sure that we do pretty much the same stuff that we want. So we're going to be creating our hero. So here we leverage our create hero function. So this is once again is the function that comes from our models, and this function is supposed to receive a bunch of things. So it's waiting, as you can see, to receive a name, a secret identity, a user ID, and a weakness. So here, once again, just to get the user ID, let's leverage pretty much the same thing we had in all our other stuff. Require user ID. We pass it our request. And now we're going to get the user ID, so we can just pass it here. So now we need to have access to the other type of stuff. So how do we do this? Remix is going to be, whenever we do a post, this is going to be sent through the form data. So now we need to have access to the form data. So how do we get the form data? This form data comes in our request. So pretty much by accessing our request, we can ask it, okay, request, give me the form data that was sent through you to post. So now that you have this data, we can just say, okay, form data, I want to get the name attribute. So now we're going to be doing this to secret identity and for weaknesses. So weakness, the same thing in here, and secret identity. And the same thing in here. So pretty much what this is going to be doing is when in our identity, in our inputs, whenever we fill the name, the secret identity, then weakness, and do a post, we send this data through here and we leverage it. Okay, so now we have this data. We can create our hero, right? We just send our name, we just send our weakness, we send our secret identity, and TypeScript is yelling at me again because, well, the return of a form data can either be an entry value or it can be null. So for some reason, the data cannot be sent through the form. So now we have to handle this scenario so that TypeScript stops yelling at us once again. So we just do an assertion where if type of name, oh sorry, type of name is different from string, and we do the same thing for all the other attributes. So we just need to make sure that if for some reason the type of these attributes is not a string, we're going to be handling it. So if it's not a string and it's not a weakness, it's not a string, you're going to be letting the user know that something went wrong. So to make it easier, I like to create a function called bad request, which is a function that it's going to be receiving my data. So the data that comes from our action, and the data that's supposed to return from our action is our action data. So using this bad request, what I'm going to be doing pretty much is just leveraging the JSON again. Okay, I need to import it. And letting the user know that, okay, this data went wrong, and just get a 400, because there was a bad request when trying to create our form. Something did not work properly. So in this type of function, in this if here, whenever we're going to have an error, we just let the user know that there was a bad request, and we send it with a form error that your data is not valid, because for some reason we receive data that it's not a string. Okay, so right now, as you can see, TypeScript stayed quiet because now it knows that the data that it's going to be here is supposed to be valid. So once we create our hero, we're just going to want to be doing something. Okay, I'm going to create the hero, but I'm not going to want to stay on my form. I want to, okay, now, for instance, see my hero data that I just created. So here, instead of returning the data, we're going to let Remix know that, okay, we're going to have to redirect you to the route that it's going to have this user so that you can see its data. So here, we leverage the redirect function that it's going to be import from upstairs, from here. And pretty much what this redirect does, it's setting a response with the location header and with the status 302, so that it knows that it's going to be redirected, and this is the new point that it wants to go to. So in here, we're just going to let the user know that, okay, we want to go to the routes heroes, and we're going to go to the place where the hero ID is, because after we create a hero, this is going to return the new data of my hero. So if everything is working properly, which I hope it is, we just refetch this. If I go here and just say, okay, Green Lantern, the secret identity, Al Jordan, and the weakness, fear, if I save this, it should do the post, because, okay, now the mutation happened successfully and it triggered the redirect. So everything is working properly, right? There's just one thing that we forgot, because there's nothing stopping me from doing this. So right now, when I do a post, we are not validating if we have invalid data, if we are sending empty data. So let's just take care of this really quick. For this, I like to create a simple function called validateEmpty. And this is a function that it's going to be receiving a value, which is supposed to be a string. And if our value dot length is 0, we're going to just return this field is required. Or if it's not, right now let's just send undefined so it's easier. Now let's use this function inside of here. So now we already know that it's not a string, that whenever it passes this if, it's going to be a string, so we just need to assert that the string is not empty, it's valid. So the way I do it here is creating an errors page. And here for each attribute, I just call validate if empty, and I pass it the name. And then I do the same thing for weakness, and the same thing for secret identity. So this errors object is going to pretty much checking everything if it's empty. So now we just have the user know, okay, the data that you added, it's not valid. So once again, how do we do this? We create an if condition where we're going to be doing object.values, because this is pretty much going to be returning all the values of my errors object. And if some of them happens to be a Boolean, so if some of them happens to have a string, it's going to be valid. Then I just want to return a bad request. Where here we're going to be sending our errors, and inside of our fields, we're going to be sending the current data because we want to make sure that whenever the page reloads after a post and if there's an error, we still continue displaying the data on the form. So here we pass it the name, the weakness, and the secret identity. Okay, so this should work, but there's just one thing that we are forgetting. We are not passing our action data to our component. So here, action data. Like the user loader data, there's a function, a hook. Here we have a use action data, where we're pretty much going to average our action data. And in here, now as action data, so it's TypeScript knows that it's supposed to be this, and inside of our hero component creator, we pass it this action data. Okay, so now if we go back to our hero and we try to save, it's going to let us know, okay, everything here is required because, well, our data is required. So let's just add new data. Jason. Okay, Todd, weakness, Joker, something like that. So once again, as you can see, everything is working properly. We created fetching data, we did some mutations. Now I just don't like having this data here, so let's create one more action just to handle a deletion in this scenario. So inside of our hero ID, let's create a form where the method is going to be a post once again. And in this form, we're going to have a button that's going to be responsible for doing whatever we want. Let me just copy something in here so it's easier and it's going to save time. So this is going to be a button with a type submit. It has this class name, and in here we're going to want to be delete hero. Okay, so this button is created, form is created, this is inside of a div. I just need to import my form component. Okay, form component here. So if I save, I need to format this because this is super ugly. Okay, why is it not formatting? There's an error here somehow. Oh, okay, oh, this is not supposed to be here. Yes, it is, sorry. Okay, so now it should format properly. So now if we go in here, we have a delete button. But if we click it, there's no method allowed because once again, we didn't create our action. So just to set up our action, we're going to create a simple function once again, export const action, action function, just to type it once again so TypeScript knows it. And this is going once again going to be an asynchronous function, and I'm just going to copy this part for the sake of time because it's going to be pretty much the same thing. Because we're going to be needing to validate, and we are going to be using the param ID so that we can trigger delete for that specific ID. So now what we're going to be doing, now that we have a hero ID and the user ID, is called a function called delete hero. So this function receives an ID, which is going to be our parameters hero ID, hero ID, and it takes a user ID. So after delete, we don't want to continue on the same page, so we're just going to trigger a redirect to our old page, to our heroes page. So here, I'm just going to trigger a redirect to heroes. Okay, I just need to import redirect and action function. Okay, so now that this is done, if we go back into here and I delete it, oops, it didn't work. So what did we fail in here? So there's a wait, oops, okay, this is awaitable. I need to wait for this. We pass it the hero parameter. Let's check this again. Okay, now it's deleted. We needed to wait for the request to be triggered. So yeah, this pretty much wraps up the coding part of the presentation. Just a small part that I would like to show to you before it ends. Okay, I need to go back to my slides because for some reason I closed them. And this doesn't have, so let me just once again go back in here. If the internet allows me. But pretty much what we saw in here was the simple things that we might need to do remix in use remix nowadays: loaders, actions, and okay, this is showing the notes, and I don't want to show the speaker notes. Not have speaker notes as well. I just broke this. Technical problem. So what we were seeing in that slide, and I'm just going to show here real quick if I want to go back into it. Okay, cool. What we were seeing in that slide, and it was pretty much the last thing here, is that Remix gives you a bunch of stacks to use for stuff that we need. The stack that I used here for this demo was the Indie stack, which pretty much comes pre-built with Prisma, SQLite, FlyIO, so you can deploy to there, Cypress, and pretty much bunch of things. All these stacks depend on the stuff that you're going to be needing to use your application. Now, a point that is often asked is, okay, but I'm using Next. Should I stop using Next and use Remix? The answer is no, for most cases, because if you're already using it right now, it doesn't kind of make sense to stop everything that you're doing and migrate to Remix. It, while Next handles stuff on a server-side generation way, Remix handles it on an SSR way. There are stuff here that Remix is faster than Node, for instance, serving dynamic content, because while Remix just fetches the data and populates everything that it's pre-built with it, with this data. With Next, we are going to either have to fetch the data in a client side, or we're going to have to trigger another build with the new data. Couple of stuff that it makes it faster with Remix. It enables faster user experience, even on slow networks. Another thing, it handles automatic errors, interruption and race conditions, and build times are nearly instant decoupled from data. And one final thing, just to wrap up, because I actually forgot to show you this. I'm just going to go in here and in my notes, and I'm going to be disable JavaScript. So, as you can see, Remix can work without JavaScript. And this is something super powerful. Like I said in the beginning, JavaScript is what in Remix can be added as progressive enhancement. And this is what makes Remix super fast and super powerful. So, yeah, with that said, and just to wrap up, thank you for watching this talk. Like I said, I'm a developer advocate at the OX group. We have a booth in the sponsors booth, so please make sure to check and speak with the amazing people that are there. And thank you all. This is my Twitter QR code if you want to scan it. So while you are there, I'm just going to ask for a quick photo with all of you so I can share it. So make sure to cry or smile or whatever. Okay, so thank you so much, everyone. This was amazing. If you see me around, please make sure to come speak with me.
isso dificulta a logística? Ok, está bem. Está bem, está bem. Está-se bem. Sim, eu faço uma apresentação no início. Estão-me a ouvir? Oi? Um, dois? Ok. Então, sorry, switching to English, yes. Yeah, welcome to this talk. So, are gonna get started with blockchain. So for that, we will kind of go a bit first on the goals. So we will go over some blockchain concepts, of course. First, who here has blockchain? Crypto, tokens, digital assets, NFTs? Hands in the air. Okay, okay. A friendly crowd, I'm saying. Okay, let's go. So we'll go also over some blockchain context, specifically targeted at the practical side, okay? And then our goal, our end goal, is to create a custody service. What is a custody service? Basically, it's a service, right, that holds our cryptographic material for us and allows us to do the operations that we want to do on the blockchain. So this is basically your app that you use on your mobile, your extension on your browser, for example, MetaMask. Basically, we are going to do that, but in a way that we can, for example, an example is building a custody, or sorry, an exchange service, for example, a Binance, a Coinbase, all of them do what we are going to do here. We are going to see just a tiny bit, but yeah, so the major features will be, we will do withdrawals, so moving money out of our system into an external account. We will do deposits, so detecting money coming into our system to one account within our system. And of course, we need to see the balance just for the sake of knowing how much money we have. But yeah, first a little bit about me. My name is Gonçalo Pereira. I'm here from Coimbra. I've been a backend engineer for over 8 years, and I've been mainly involved in the business critical markets, always with a ton of security involved. And since 2001, since last year, I joined Anchorage Digital, and I started working with blockchain and digital assets. Digital assets here, it's everything associated with blockchain. Can be a cryptocurrency, can be a token, but it can also be, for example, an unfungible asset, an NFT. There's a whole array of stuff. So, but yeah, let's go into it. So let's start first for those of here that are not really, oh, by the way, as we go, mainly on the, even more on the code side, feel free to raise your hand and make questions so that we can all go the same pace, go the same, and understand what we are here. Hopefully, I'm good at giving my message across. So yeah, let's go blockchain. So reducing it bare minimum, blockchain is a word conjunction, right? The grouping of the words block and chain, okay? What does this mean? So this means that it's a chain of blocks. Each block will have transactions within it, okay? These transactions can be what we normally identify as a transaction, so moving funds, but they can also be, in the case, for example, of Ethereum and other similar blockchains, it can also be, for example, executing code on a smart contract on the blockchain, or deploying a new smart code, a smart contract, sorry. And these blocks form a chain because each block kind of points to the previous block, all the way until we reach the first block, the Genesis block, okay? It's the name that they called the first block of all. And for example, in the case of Ethereum, this block was created on the 30th of July, 2015, okay? And a new block, in the case of Ethereum again, has been added more or less 13, 14 minutes, every single 13, 14 minutes, a new block has been added. So now we are, yeah, up to a big number. And as the time flies, we get new blocks added. So this is the main gist of blockchain. Here, the transactions that happen in the blocks can be, again, what we normally identify as a transaction, right? So moving funds, for example, 1.01 Ethereum, to some other address. Can also be, for example, executing a function X with parameters Y on a contract located at a certain address, and of course can be the deployment of that address. So, okay. Another part to blockchain is the network effect. It's actually what creates the decentralization properties of blockchain. So blockchain is a distributed network. Again, very basic stuff. It is composed by a lot of clients. These clients have to implement a certain protocol, for example, the Ethereum protocol, and they can be both developed by the Ethereum Foundation, for example, the team behind the Ethereum project, or can be by other team as well as long as they follow the spec. And naturally, these blocks are connected, right, to each other, so they discover and communicate between themselves. And what do they communicate for? Achieve consensus, agree on the blockchain state. Each and every single one of them will have a copy of the blockchain. There is no single source of truth. Okay, there's also it's where the decentralization comes from, and they must run an algorithm in order to agree on we can say the network state. Okay, so the majority of the nodes, the majority or the state of the majority of the nodes wins the state overall, and they agree. And this will be important as we will see implementing our custody service. Okay, understanding if a transaction went successful or not. So yeah, but let's go to brief introduction. The goal is just to introduce some concepts, just for you not to be listening to me saying strange words. So yeah, so our goal will be to implement a service, again, a custody service that can do the withdraw, deposit, and check balance. So going a bit more specifically, we call it withdraw because we are sending funds from an internal address, an account internal to our system, to an account outside of our system. And deposit the other way around, outside to inside. And then, of course, the balance, we need to make sense of everything that is happening on the blockchain. So yeah, let's go into a practical example. So we want to build a custody service, but in order to build such a custody service, we will need to interact with the blockchain. Okay, so we need a gateway to interact with the blockchain, and it will be exactly one of these nodes. We need to run our own node. We could also use a public node, but again, as in software, using something of a third party, we are dependent on that third party. So we want to, okay, oh, okay. So yeah, to build our own, let's go. I've already prepared here a kind of a setup. So I have here a Docker file. Can you see? Yeah, can see. Yeah. So I've built here a Docker file. So basically, this is piggybacking on top of the official image by the Ethereum community, the Ethereum Foundation. So I'm going off the main Ethereum client and building my stuff. Here, important stuff. So I'm making a local network, okay? I'm not connecting to the main network. So I'm having my own Ethereum network. I can have how much or whatever much Ethereum I want in this specific network. And so to do that, to build that first block, that Genesis block, essentially we have to create this file, this Genesis JSON file. And what we are saying here is we are giving a ton of configurations. One important one, the one on top, the chain ID, is like an identifier of our particular chain. This is more like to avoid us from sending a transaction to the Ethereum mainnet, which was targeted at some other mainnet or some other network compatible with that Ethereum mainnet. For example, I don't know, the Binance Smart Chain is an example of a Ethereum copy. So yeah, we want a specific one. I just made up this number. And another thing that I've configured here is a first allocation of address. So from the start, these three addresses will have a certain amount of Ethereum. Okay, this is Ethereum has 18 decimals, so if you exclude the 18 zeros, believe me, that's 18, we get on one account 1 Ethereum, okay? On another, we get 999. Okay, yeah, sure. Let's run our node and see and check it out. Let's see how. Oh, by the way, I have a Docker Compose here just to make things tidy. Here, we have our port that we will use. We will use a HTTP JSON RPC interface, okay, to connect to our node, to interact with it. So I'm here exposing that port, 8545. So running it, I'm just building it for the sake of it. We can see that it is indeed running. And if we look at our container, we can see that we are doing a ton of stuff here. A ton of stuff is happening here. So mainly what is happening, you can already identify a nice phrase, mined potential block. So our network is both providing the gateway into or this node is both providing the gateway into my local blockchain network, as well as mining new blocks, okay? So of course, this is just for local purposes, local development purposes, not an actual blockchain for production purposes. But here, we can see that we are constantly mining blocks. So we are seeing we mine the number 10, now 11, 12, 13. So each 5 seconds we are mining a new block, okay? And we will see whenever we send transactions, they will appear here and they will be included into a block. Again, following the full blockchain as it grows, and we will naturally interact with this. So yeah, we have our node running. One thing that we can do, for example, is we can use, for example, here MetaMask. Who here has interacted, used MetaMask? Yeah, a ton of people, right? Pretty wide adoption of MetaMask. So here I'm connecting specifically to my network. Just to, I've set up here some accounts, and let me just make sure that I reset the account information on MetaMask, just to make sure that it is indeed connecting to my new instance, and it has already picked up the balances. So 1 ETH on the account starting 59, and we have 999 on the account started with B4. Okay, so we have balance. Everything is okay. We have a wallet that we already know that it is working and it's fully functional, is detecting the balances, and will also detect the transactions happening on the network. So basically, we are gonna build our service to do mostly the same thing that is happening here. Okay? Any questions so far? No? Okay. I'm gonna assume that we are going okay. Yeah, so let's go into the actually building our service. So again, in order to do that, we will need to connect to our client. We will do that using an HTTP RPC JSON interface. That interface is specified by the Ethereum Foundation. It's the actual protocol, one of the parts of the specification of these clients, and this is the RPC specification that we are going to use. For example, we can see some stuff here. For example, this one, ETH chain ID. To get that chain ID, we can get, for example, one here. We are interested in creating a transaction, so we can see here the send draw transaction. Okay, so we send here a string of X encoded bytes, okay, and we send it to the network. And we will use some other parameters here, but we will discuss them as some other methods here, but we will discuss them as we go building our service. So yeah, let's go into code. I've set up here a Quarkus application, okay, a very standard Quarkus application. Let's look into the POM file. So basically, okay, we are here using Java 11, going for one of the pretty recent version of Quarkus. And the most interesting part here is this dependency, so the Web3J dependency. Okay, this is our dependency that will wrap these endpoints. It will handle encoding, decoding. It's like, for example, JaxB, for example, or Jackson. So it will handle that part, plus knowing the endpoints, knowing how to invoke them, and so forth. So will do a lot of heavy lifting for us. And also, for example, handle things like signing the message, building a message. We will see. So we have that. We have here a ton of stuff that I've built some example repositories. They are holding data in memory, but imagine that they would go to the database doing things properly, of course. But going into our specific case, so we want to build the withdraw function first. So again, going back to it, a withdraw function is sending a transaction from one of our accounts into an external account. Okay? So we want to build a transaction where we say, okay, from this address, we send money into that address. Here, of course, we are reducing it to sending money, but could be a smart contract invocation. Okay? So to do that, I've built here an endpoint. Imagine that this would be a REST endpoint here with /operations. Okay. If we do a post, we are creating a new operation. Doesn't really make sense to create deposit operations because they come from the outside. So we are creating a withdraw operation. And here on our model, we are getting an amount, a recipient, of course, it's to whom we will send the funds. And we also have here a sender. The sender would be the account associated with the user logged into our service. Here we are kind of just cutting corners and sending it right away in the payload. So we are specifying the sender. The sender is sending this amount to this recipient. Okay. So starting first, let's just do first some sanitization, just because, for example, the addresses in Ethereum, they can be mixed case, okay? So addresses, I don't know if you have looked at an address. I can show you here. For example, this would be an address, okay? This would be one of our addresses. So they can have mixed case, as you can see. And the purpose of this is for checksum purposes. When we are writing the address, by like copying or something, it makes sure that we do not make mistakes. At least picks up some certain degree of mistakes. So in order to kind of forget that and make sure that our matches are correct, we are gonna do just a lowercase. So this is our sender address. So let's do the same thing for the recipient. Lowercase, and we will say, okay, a recipient. Okay, and let's also extract the amount right away and say that this is a string, so let's go and pull it into a big integer. As you saw, the precision in Ethereum has at least 18 decimal cases, so yeah, gets pretty big, the values. And here, okay, let's just rename this to amount. Okay, so we have sanitized our addresses. Naturally, here we would do a ton of stuff. For example, validating that the user sending the amount has enough money to send that amount. Otherwise, it will simply fail on chain, on the blockchain. Other stuff would be, for example, okay, checking if this address is correct, checking if the recipient is correct. So we would need to do a lot of validations. But at a certain point, we would reach the actually building the transaction. So here, it's one part where Web3J kind of leverages and helps us out. So we can have here a class that you can just create here a static method, create Ether transaction. And we have a ton of parameters here. So first we have a chain ID, again, to make sure that we are targeting our correct network and not a test network or whatever. So we'll also have announce. We will go over what this is in a minute. We have our gas limit. The gas limit for, this is things specific to Ethereum, but the gas limit here will always be the same value because we are sending ETH transactions, so we can just use a constant here. And we will, of course, say where to. We are sending this. We want the, the recipient. And we will also want the value, which is our amount that we have pulled before. And then we have here two parameters. I will explain what this is. So this is a big and important mechanism in blockchain, which are the fees that you pay to send the transactions. So let's go and say, call it tip fee, and call this one max fee. Okay, so yeah, we have a ton of stuff to calculate before we create this transaction. So let's start maybe with the first, the nonce. Okay, the nonce is a mechanism for protecting against entry replay. So this is a number, a counter, which is capped on the blockchain, okay? And is incremented as we send new transactions. So this makes sure that if we try to send the same transaction twice, or two transactions with the same nonce, one of them will be rejected. So it's just a protection parameter. Again, using Web3j, we want to go into the blockchain to fetch that data. We would use the this example, this one here, get transaction count. So we want to send the address, and we want to this is a parameter which allows us to kind of configure what exactly we want the transaction count from where we want them. We will actually want every single transaction count, so we will use a value here, the pending value. I've already done this here, but let's just get transaction count. So we would say, okay, we want the transaction count from the sender, the party sending the transaction. And we would say, okay, default parameter name, we would use the value pending, okay? I've already done here a utility method for that, which is here, a compute account nonce. So basically, yeah, we are doing the same thing. Get transaction count, we are saying the address, and always pending. So let's just call that compute account nonce. Okay, we want the sender, and that's it. So one part done. So now we enter a bit of a complex land. We enter the area of fees in blockchain. So fees in blockchain are very important because as the network is a decentralized network and a trustless network, it really doesn't control who is sending the transaction. If it is an authorized party, good intentions party, whatever. And so in order, for example, to protect against denial of service attacks, like people just spamming tons of transactions into the network just to bottleneck the network, we kind of have a mechanism where we have to pay for each transaction sent to the network, okay? We are paying, in this case, we call it gas, but it translates back to Ethereum. It's actually Ethereum. We are paying Ethereum, and we have to have the transaction being broadcasted, being accepted to the network. And here, these fees have an interesting mechanism. So it has changed at least, I would say, 2 times or 3 times. Slightly now a big change in the middle of last year. And we have 3 parts to the fee mechanism. We have a base fee, we have a tip fee, and we have a max fee. Again, this is specific to the Ethereum blockchain, but other mechanisms similar to this one occur on other blockchains. Okay, it's always you have to pay in order to send transactions. The way you calculate it might be different. So we have a base fee. The base fee is always changing. It is the parameter which responds to network congestion. So it increases if the last block was very full. It decreases if the last block was almost empty. So it's kind of always shifting. So we have to account for it, and in order to account for it, where do we go fetch that data? From the blockchain. Okay, and again, we leverage our library, of course, to go, and we have here the gas price. This is a bit of a legacy name. Okay, this was changed in the last year. There's a bit of a legacy name. So we go fetch this gas price. It will actually be the base fee of the last known block. So we call it, and we have here. Oh, by the way, I haven't yet explained this. So this library has a mechanism where it can do both synchronous requests or asynchronous requests, and you can leverage reactive patterns on top of it. Here, for simplicity, I'm just using the synchronous, so it will be block on this send call, and it will only unblock when the client replies back to our request. And sorry, any question? Oh, okay. So yeah, so we get this base fee. Let's just call it a better name. Oh, it's a request. Let's give it like that. And we have to check if because of the way this library works, we have to check if we have errors. If we have errors, handle. Yeah, sure. Let's just postpone it. Yeah, it will be handled to the next developer coming in. And okay, sure, we have our gas price. Here we get the gas price, comes as a big integer, and we say, okay, this is the base, let's call it properly, the base fee. This is the base fee, okay? Again, this base fee is changing almost in each and every single block. And so we want to have here also an incentive for the people creating, or they call it in Ethereum right now, miners. Like it's the whole spending energy to validate blockchain now and how it's bad for the environment and whatever narrative. And here, what we are paying to those miners, the incentive for them to mine our block, to include our block over others, is a tip. Okay, kind of like the waiter in the United States where we pay the fee. So in order to compute that fee, for example, we could use whatever method we could think of. But here, for example, let's use the base fee. Okay, let's convert it to big decimal just for the sake of doing divisions and multiplications. And let's multiply it here for, I've already created here a constant 0.1, so 10% of the base value. So we are always paying proportionally to the base value. It's not a great approach, but yeah. And this will, of course, maybe do, so like we may just to make sure that we do not create here and we to big integration. Yeah, that's it. And okay, so tip fee, that's it. So we are calculating 10% of our base fee, okay, and making sure that we are always paying that. But again, one thing kind of can left us thinking here, because if this base fee is always changing, and if, for example, we do not specify enough tip fee, our transaction might be just delayed, and when it is added, we will pay, like, I don't know, for example, a ton of money to include our transaction. So we kind of, it's always good to have a capping portion to it. So the capping portion is like the max overall that we are willing to pay. Okay, and in order to calculate that, you are already kind of figuring this out, right? It's the base fee is always changing. The tip fee is on top of that. So we will allow some degree of variation on the base fee, add it the tip fee, and that's the overall maximum. Let's say the reasonable value is for it the base fee to like double. Okay, let's say it's okay for them to double. We are willing to pay that. So we have the tip fee, and given this, we have our max fee, the thing that we are willing to pay for this transaction. Okay, I've used the same name, so all of them have already plugged nicely into our raw transaction. Another part is we want to broadcast that transaction. Okay, if we did things just this way, nothing is really protecting our, nothing is really identifying us as the owner of this account, this address. So everyone could simply build this transaction, broadcast it on a random client, and be accepted. So we have to build another layer, have to build an additional security layer on top of our transaction, which is signing it. Okay, I'm sure that the people that has already used blockchain so far knows that things are signed and you have to keep your keys private, and that's the way that things are secure. Here, this is a bit of a big no-no to do, but here I've just placed my private keys here on this file. Feel free to grab them and use them, whatever. I just generated a random accounts. So, but just for the sake of being simple, I've here detailed my wallets, the address, the initial balance, which matches our Genesis JSON configuration file and our initial block, and their private key, of course. And so going into the signing part of the transaction, so we have to load these credentials. We have to load this private key. So like let's load the credentials. So again here, basically this is just from that string creating an elliptic curve pair. So Ethereum uses elliptic curve key pairs, and with this utility, we can create the credentials from our key pair. We will have to fetch that data, so we can. I've built here a wallet repository. Basically, it loads that application properties file and just saves it into a map in memory. And so we do get wallet, the sender wallet, of course, and we have here our wallet. This is an optional, so we would need to check if it is empty, okay, if it is, handle, whatever, okay. And if we do handle, if we do have the wallet, we can then extract that private key. So we do get, and we do get private key, and it will create our credentials for us, okay. We can just inspect here, see, EC private key pair, create from that private key. Pretty standard cryptography stuff. So just a utility method that Web3j gives us. So again, we have the credentials, we have our transaction, we have to sign it, remembering signing. We have to sign our transaction. And to sign the transaction, again, Web3j, the RESCO, it gives us some transaction encoder utils here, and we can just say, okay, sign my message, give it the raw transaction, and of course, here's the credentials. Sign it for me. And here it goes. Some bytes come out. So this is the signed transaction. You can say bytes. Okay. And we have our transaction signed. So it's ready to be sent. Actually, it's not ready because here on the send raw transaction, it requests a string of encoded bytes. So yeah, we have to put it into X encoding. Okay. So Here you could use whatever. Here I'm using what Web3j also provides, and so this is the actual signed transaction. So this is the actual signed transaction. It's the one that we can send. Again, let's use the endpoint. Let's call it, send it, and send transaction, raw transaction, and that's the signed transaction. Oh, here I need to do the same thing, send, and then var. And that's it. So we have here our response. As we did countless times now, we have to verify if it has an error. If it has, let's handle it, whatever. Okay, so given this, what we already have is a submitted transaction. But here, let's first register inside our service layer. Let's just first, okay, so we create. I have already here all these bins created, and we have a ton of stuff here to fill. So the transaction ID, it will be the returned by this response, get transaction hash. We will have here the state. So the state will be, we have two states. Let's first fill in the rest, and then I will piggyback off that. So we have the sender, we have the recipient. Again, it's just filling in our stuff here. The type will be, we will have two operation types, withdraw and deposit. So we want the withdraw, definitely. And submitted that, so we can just say, yeah, no. And that's about it. Oh, we are missing the amount. Here we are, I don't know why I put the string instead of the big integer, but yeah. So if I'm not missing anything, we are only missing the state, if I'm recalling correctly. So the state here, it's another layer of complexity, mainly driven by the distributed nature of the blockchain. So the state, when we send a transaction into the network, it might be successful or it might fail. So there is no guarantee that the transaction we send to the blockchain is successful. One way it can go wrong is the fee. We not paying enough for the transaction to be included. And if we do not do that, the transaction will simply hold on, be stuck, trying to get into a block, and we will have to rebroadcast it, first increasing the fee, naturally, putting another nonce, and rebroadcasting it. We can also cancel the last one. It's sending a transaction with the amount of 0. But yeah, so we kind of have here a bit of a pickle, right? Our operation is in broadcasting state, but we have to make sure that it either fails or it either is successful. If it fails, we will have to potentially broadcast it again. So how do we do that? One way that we could do that is here we have one endpoint that gives us that information. So it's the receipt. Where is it? It's below here. So we specify the hash, okay, and it gives us the receipt information. This can either appear or like be returned, right? It responds successfully, but it can either contain something or nothing. And if it does not contain anything, it means that it wasn't yet included into a block. It wasn't yet included into the blockchain, okay? And for example, stuff that only appears in this information is, for example, the actual gas used and the effective gas price that we paid for that transaction. So we have to kind of go and get this object to know exactly how much we paid for that transaction. Otherwise, when we submit, we are just estimating. It will be from the base fee plus tip up until doubling the base fee plus tip. It's the max fee that we calculated previously. So we could use this get receipt that transaction received. The thing is, if you start thinking about it, this won't really scale, right? Because every single transaction that you submit to the network, you will need to be constantly pulling on the network, checking if they're included or not. Each and every single transaction that you submit. So yeah, not really scalable. We have to find another way to do it. And a way to do it, it's a common practice, and even it's translatable to a ton of blockchains. Of course, you might be thinking, why doesn't the client notifies us of a completed transaction, accepted transaction? We could do that, but the thing is, we would have to keep constantly telling the node, oh, these are the transactions that we are interested. If, for example, imagine that we manage the node in a Kubernetes. If we have to wipe out our state, for example, reboot it again and load the full blockchain again because something got corrupted or whatever, our backend would have to go and load every single hash that we are interested, every single transaction ID, transaction hash that we are interested into that node, so that that node can then report us back. And how about if that's the only node that we have? How about if we, because of this mechanism, we fail to notice some transaction, right? It's not like foolproof. A foolproof method is one that I've here added. And I was planning on doing this also live coding, but I took a wise decision to not to do it because I only have 8 minutes and 40 seconds. And here, so what we are doing this here is we are scanning the network, okay? What does that mean? So we are going to the network and fetching the last known block, last included block, okay? We are doing this using this Web3j block number. So it gives us what we call in blockchain the network height, the blockchain tip, the blockchain height, the block height. And that value will be, for example, here. Let's look at our node that is here, hard working mining blocks. So right now we are at the number 378. The block 378. It's like it's on the corner, the bottom. 379, 380. So we are constantly mining blocks. So we will get that value. And then here I'm initializing the application with a 0 value. And here what we will do is, okay, so we know that the last one that we have scanned is a 0. So we know now that we have 300 and whatever blocks. So we will go and ask each and every single block between those two ranges and get that block, okay? So here we are doing that while. So while comparing the block being scanned with the last tip height, last known block number, okay, while it's still less or equal. And we are going to scan the block. And to scan the block, we are going to, of course, get the block information. So get block by number. It gives us the information on the block. This includes, naturally, the transactions, a list of transactions, and us by having here a list of transactions. So here we have a list of transaction results. These transaction results will actually contain the transaction. So we have to look at each transaction within each of the blocks we are scanning. And to do that, again, I've already implemented this scan transaction. And for that scan transaction, we go into the object. We go and fetch that other information that we were talking. It could be an alternative, although a poorly scalable one. So we get the receipt. We have to compute exactly how much we use to pay for that transaction, right? So we get transaction receipt, we get the effective gas price. Here I'm just converting because it comes in eggs, so removing the 0x and then converting from base 16 into base 10. And we are also gonna get here the gas usage. So how much did you pay? It's the gas used times the price. Pretty straightforward, yeah? So this was the amount in Ethereum that we paid for this transaction. And of course, we have to process. So here I'm creating a temporary object. And so it's from this sender to this recipient, paying this fee with this hash, with this amount. Okay, so we know exactly, we have extracted the transaction data from the blockchain. And now we are at the point where we can decide, was this a withdrawal? Was this a deposit? How should we look at this? And here, that's exactly what we are doing. So we are going into our wallet repository, finding, okay, is the sender in our system? If it is, we are processing the withdrawal, so we update the balance, and we mark the transaction here as confirmed. So it will change state from broadcasting to confirmed. For the deposits, it's already here also implemented, so we just did both stuff with the same scanning stuff. So we are both confirming withdrawals, and we are also detecting the deposits, because a deposit is a transaction that the recipient is in our system. A withdrawal is a transaction that the sender is in our system. Here, since I have set up two accounts in our system, we are kind of going to get both a registration of a deposit and a withdrawal and a deposit. So, but let's check it out so I'm here running our Quarkus dev, just to make sure that, again, our node is already running fast, working. And here we can already see, oh, it already picked our blocks, so scanned 430 blocks. It didn't pick anything because we haven't done anything on our network. So now 2 blocks more, so it will just keep working at this. You can already see this is a lot more scalable because we are pulling at a constant rate, right? We are pulling at a rate acceptable to detect on a timely manner the new blocks being added. We don't have to pull faster if we have more users, which would not be the case if we went with a receipt approach. So let's see it working, right? I think I have a bit of time to see it working. So here we will send an operation given the B4 sender and the 59 recipient. I'm sending 100 ETH. So I can check here the operation. Here it's broadcasting. You already saw on the top submit a transaction. Oh, it's already running away. Here, submit a transaction. Okay, it got received, and then it got mined into a block here. So it went into the 442 block, the blockchain. If we check again on the state, we already have it marked as confirmed, and we got here a deposit. Why? Because I'm sending a transaction as a withdrawal, but the sender, the recipient, is also on our system. So we kind of detect both the withdrawal and then the deposit back into our system. So we get two operations. Okay? If we check, just to make sure that I've not you fooled, guys, if we check the MetaMask account, so this one has 999, the balance. Now it has minus 100. Actually, it is a bit less. If you see, MetaMask is rounding here, but because of why? The fees. We had to pay for the fees, so we do not actually have 899, we have a little less. And the other one has 1, so now it has 100. And if we now send back the, let's send it back. We are good guys, the guy mistakenly sent this fund, so we are gonna send them back because we are very nice. So we are here, we are sending the transaction. Let's switch back fast into our scan. And let's see if, oh, we just pick the same transaction as both the withdrawal and the deposit, again, because we are sending from one of our accounts into some other account. And if we go and fetch the operation, so we add 2 operations, now we get 4 operations total. Okay? So we are making withdrawals, we are detecting deposits, and we are, I had here an endpoint also to check the balance, but the balance will be easier, right? We are updating the balance on each transaction. And running out of time. So just as a wrap up about Anchorage Digital. So basically this is what we do in our day-to-day. So we integrate with blockchains. We actually provide what Anchorage is a platform for digital assets targeted at institutional investors, so banks, venture capitalists, fintechs, and what we provide is a custody service at heart, right? Being secure, bringing the security best practices of the industry into the custody of digital assets. So for example, this was created because our clients would have either a cold wallet, like a USB stick. I don't know how much of you are aware of those cold wallets, for example, kept in a safe, and they would only open the safe when they wanted to perform a transaction, or for example, have a phone just for that purpose, kept again away at the safe. Some also used more like multi-sig stuff where each person had a part of the basically a part of the private key, and they would gather all together in a safe space just to gather the pieces and to do the transaction. It was a real nightmare. So Anchorage Digital comes and fixes that problem, and on top of it, we provide a ton of added value, stuff that clients want to do on blockchains: governance, financing. We have a brokerage product. We have a finance product like lending and borrowing, and we solve problems for both crypto projects, for example, the Celo and Coin and Oasis. They are all blockchains. They have their foundation reserves, their reserves of crypto in our custody service. We also solve problems for infrastructure providers, what we would call fintechs, for example, Square and Visa, 2 big, giant payment processors. And of course, we heavily integrate with and heavily comply with all the regulators in the market to provide a safe, compliant, and up to standards, to security standards, to engineering standards, to keep digital assets, not other digital assets. And that's about it. I don't know. Don't know if we maybe have 1 or 2 minutes. I don't know, for questions if we have them. Kind of went a bit over time. Yeah. Sorry, I did not understood.
Okay, hello. Thank you. Yeah, the status that you have in your applications are status that you define, or these are actual status that are in the blockchain. For example, confirm this belongs to the blockchain or it belongs to your application.
Yeah, so when we create the withdraw operation, we register that in our database. It's everything is in memory, but imagine in our database. But then everything, like the transaction being broadcasted, goes into the actual blockchain. The data is always kept in the blockchain. Okay, the data is all on that this Docker node that I showed you that is still running. So this is our node that holds the full blockchain data for us, the full ledger.
And if you set the not correct limit, your transaction can be living forever, waiting for a confirmation in the blockchain.
Yeah,
in the Ethereum.
yeah, Yeah, basically it can. For the sake of managing here the space and memory, right, on these nodes, they normally have some sort of a timeout where they start dropping out stuff. But yeah, that's the main gist of it.
Okay, thank you.
I don't know. Any further questions?
So you need to sign those messages.
Yeah.
So I believe there is a registration process where you create your key pairs. Who is actually verifying this signature, and where there are the public keys for
Great
that?
question. Great question. Yeah. So basically, the way the Ethereum, there are other blockchains that do not do like this, but the way the Ethereum and, for example, Bitcoin blockchains work is anyone can create those keys. Basically, you are randomizing that public-private key pair, right? And with that, you derive your account address, and given that, you have an identity on the blockchain. Of course, you might say, if no one is validating this, couldn't I randomly generate accounts and try to match another account already existent on the network? You could, in theory, you could. But then, yeah, randomness, statistics, right? The probability is very, very low to have that collusion. You do have on some other blockchains where you have to make a certain transaction in the network in order to create an account. Basically, we are decoupling the account from the cryptographic material. So some are doing that. For example, Ethereum is also planning on doing that, on having only accounts within the blockchain, and you have that decoupled, and so you have an extra level of wiggle room, right? Yeah. I think there was also here a question. No.
Last question.
Yeah, you can you are always also free to reach me out in the venue today, or even reach out to me on my email here. Yeah.
So Gonzalo, this might be a dummy or newbie question because I'm quite new to this stuff, but it seemed like pretty easy to create an application. I know that there's a change upcoming in theory, which is the change from proof of work to proof of stake, right?
Yeah.
What would it change in writing this application? Like, would we still have a concept of base fees, tips, gas fees,
Yeah.
or would it be completely different? I don't know.
Yeah.
Implementation.
Great question, and thanks for the comment. I love that you took something from here. So basically, what is changing in Ethereum is just the way the consensus is achieved. So it's changing from a proof of work algorithm into a proof of stake algorithm. So here it's just the monetary incentives that change. So instead of you spending electricity to validate the network, and for example, if you want to overcome the network and do bad stuff by yourself, you would have to have more computing power than half, like 51% of the network, right? More than half. Here, what changes is we change to a financial incentive. Okay, so in order for you to mine new blocks, it changes from mine to validate, the term validate. In order for you to validate new blocks, you have to put a stake, hence proof of stake. The stake is a monetary value that you have to put. I don't know, for example, imagine $100,000. That if you do not go together with the network, right, with the intended purpose of the network, if, for example, you are trying to include a bad transaction, if you're trying to be naughty, you will basically get slashed on that value, so you lose your money, okay? The fees are the same. If you send a transaction to the network, you are paying fees, so those which stake and are mining or validating blocks, they are getting back that fee, and they are increasing their pot, and yeah, and Some might discuss that it creates a bigger barrier of entry to meaningfully participating in the blockchain. It's a fair argument, right? For example, who here has $100,000 just to sit idle, just generating income, participating in the Ethereum network? Probably you have like a graphics card or whatever. You start saving for a graphics card and you start making a bit of a dent into. But some others would argue that yeah, with one graphics card, you aren't really going places. So it's kind of. It doesn't. It doesn't. The endpoint, the endpoints that the RPC API that we used keeps the same. So yeah, doesn't change. The inner workings are kept the same. That's, for example, one of the reasons that people should not expect a meaningful reduction in fees in the amount that you have to pay, because it's only like changing the consensus algorithm, right? It's not like scaling the network. It's not creating more bandwidth to include new transactions. So it doesn't really make much sense into the fees part. Okay, I think yeah. Feel free to reach out to me and to or to my colleagues also here. We have two more guys here. Feel free to reach out and to discuss stuff with us. Okay, thank you. Thank you a lot for being here.
Hey, bom dia. Hey,
Two, three, one.
Hello, everyone. Hey, so it's really challenging to speak immediately after lunch, as always, and also for you, but let's start. My name is Eliran Natan, and I'm a software architect at Axonius. Axonius is a cybersecurity software. And I'm very excited to be here in Jnation for the first time. And today I'm going to focus on domain-driven frontends. But before we dive into what that exactly means, I want to share with you a common problem, a common issue that we always face when we develop front-end, right? So, well, whether you read about software architecture, whether it's online or in textbooks, you always find these great monumental patterns like domain-driven design, clean architecture, microservices, event sourcing maybe. But well, I've been building scalable systems for the last decade now, and whenever it comes to front end, we always encounter this simple, monolithic layer piece of software that is usually composed of components. Sometimes it's smart or dumb components, and sometimes we have some state management solution. So I was wondering about this gap that we always have between backend and front end, and well, there is some chance, and that's I think that's the one of the most important things that I want to pass in this talk, is to use or utilize backend architecture or ideas that that emerges from backend to front end. So I think that this gap has something to do with the common assumption that domain logic, that business logic, is fundamentally more complex than presentation logic. So we don't have to have these complex patterns to handle this presentation logic. But in fact, it might have been true like 10 years ago, but in today's realities, UIs are no longer just forms and buttons, right? They are these complicated applications, game-like applications that aim to deliver this significant added value to users. And this added value, and you can think about it, the more added value that we want to deliver to users via the UI, the more complexity that we have to tackle. Yeah. So let me just give you an example from my world, cybersecurity world. Well, imagine that your platform supports some complex query language, and you want to allow users to retrieve complex data by writing some complex query. You have maybe three options to do that, right? You can allow users to directly write complex query in some input box, click the button, and retrieve the data back. And this is there is no added value to users here. You're not helping the users in creating this query, and thus you don't have any complex presentation logic to handle. You could also allow users to build dynamically some queries, like adding a pre-filled drop-down boxes, and like building this query like intuitively. And this is more complexity. This is more added value, more complexity. Of course, that you can take it to the extreme and build this graphic drop-down interface where you have canvas and users can drag and drop entities onto that canvas and make these different kind of connections. Or when they hover above the canvas with some entity, they can see where they can drop entities or not. Just think about it, how much complexity you add when you want to deliver this added value, and that complexity should be handled. And it's not part of your original business logic. It's not something that your backend can support, right? Because your backend doesn't care whether you're helping users in building these queries or not. So that leads to a new concept that I thought of. I call it presentation domain, which really means that when we introduce added value, we also introduce a new domain similar to the business domain that we are handling, but that's a new domain that emerges when we try to present the business domain. And that really encompasses all the different entities that suddenly emerges and the entire dynamics between them. So when we think about presentation domain, we starting to think in terms of, okay, let's tackle this complexity. It's not that simple anymore. So unfortunately, I think that the leading UI frameworks have trained us to think in terms of components rather in terms of presentation logic and presentation domain. Most UIs are this mixture of presentation logic and infrastructural concerns. And that presents four main issues that I've encountered quite a lot when it comes to front-end. And I've seen it quite everywhere. I was working in Manhattan, in Amsterdam, and in Tel Aviv. And when it comes to front-end, you always see the same stuff. So the first problem is testability. It's very tedious and difficult to test components, especially when they grow and are engaged in various logical concerns. The second problem is reusability. We often, when organizations grow, they want to support multiple platforms or move between frameworks. And usually they have to rewrite the entire app because presentation logic is heavily tangled with your infrastructure or your framework. And I think that some of you probably experienced this. Well, it's quite harsh to realize that you cannot reuse your application. And a deeper problem is the splittability issue. I don't think that there is such word, but I think you realize what I'm saying. It's like we often see this arbitrary or artificial division of responsibility between front-end teams. Sometimes it's about teams owning components or owning pages or views or models. But this is not how user stories are organized, right? And you usually see multiply teams have to coordinate a lot and cooperate in order to resolve a feature, right? And that creates a lot of bottlenecks, especially at scale. And the last problem, and that's probably the deeper one, is the expressibility, which means that front-end code is often composed of these synthetic or artificial made-up concepts that are invented by developers, but they don't have a real meaning from the UI perspective. Like it's very hard to understand the code, and it doesn't really naturally relates to your presentation domain. So, well, you can really see these problems emerges when you build front-end at scale, at serious scale. Now, I think that the root cause of this problem can be summarized with this sentence. We keep mixing up the what and the how. What is the presentation logic, and the how is the infrastructure. It's our data sources. It's the framework that you are using. And sometimes I think that front-end developers sometimes avoid thinking about architecture or design patterns because they expect the UI framework to implicitly deliver this design. But UI frameworks essentially won't give you a design or an architecture. That's not what they do. So what we really want to achieve, at least conceptually, is to have this core layer that captures the what, right? And it's completely logical and pure. It really represents the natural entities and processes that happens within your presentation logic. And then you want to have this infra layer, which is completely isolated from the core layer. And that really contains your data sources and frameworks. Now, most frontends today are not built that way, right? You mostly find this logic spread across the various components. And of course, that in order to mitigate the two, in order to keep your core layer isolated, you would have to have this adapters layer, this layer that mitigates between them. So that's heavily inspired from the clean architecture or other layered based architecture that you know. And that's something that I think that we can bring to front. And that, at least from my experience, that is a more scalable way to build frontends. So let me just give you an example, the concrete example. We can think about the MVVM pattern, which really matches this layered architecture idea. This is just one example for a pattern, but you can think about a lot of patterns that can work here. So MVVM is really simple. For each view, you have a view model, and the view model interacts with the actual model, right? So that really fits into the patagram that we were just talking about. So the view model acts like this adapter between the view and the model itself. Now, let me just give you a concrete example with React. So luckily, in the last few years, leading UI frameworks have realized the need to write logic and stateful logic outside of the context of components. So we don't have to do that anymore. We can extract pure logic outside of components and really achieve the architecture that I'm talking about. So this is an example of implementing the card, and I'm defining here a custom React hook. If you are a Vue fan, then of course composition API and composables is the equivalent stuff, right? You can do the same stuff. So I'm defining here a custom React hook, which is my view model. And that's a code that I really like. It's really enjoying seeing because the UI component is completely clean and easy to test. It's pretty pure. You just get all the functionality that you need and use it directly. And your view model is implemented with lower hooks, lower level hooks like useState and useEffect. And it really interacts, it can interact directly with the model. The model should expose some well-defined API, like we call it the use cases. This is also inspired from the clean architecture. And basically, it's very easy to test as well because it's a function, it's pure, and now we have a clean separation between functionality and UI. So I think that it's cool that modern React really matches these ideas. Now, of course, that UI framework is not the only thing that you want to separate from your code, right? You also have to handle the data sources, the stuff that brings that data into your app. And that's also something that we can separate, like we have some data source that is part of your infrastructure. It can be your local storage or HTTP call, Redis or whatever. And a repository, which is your adapter. So we are applying the repository pattern, again taken from the backend world. And the repository can, in fact, communicate with the repository interface that is defined as part of the core app. And this is where TypeScript really shines. Because with TypeScript, you naturally can define interfaces, abstract interfaces, and the core can rely on that repository interface. It doesn't have to know about actual repositories that use it. It doesn't have to know about the actual data sources that you're using. This makes your core app extremely scalable, and usually you don't have to change core app when you plug a new data source. So this is also very important. In order to keep your core app really isolated, you have to use dependency injection or in the invert of control, right? Because you don't want your model to directly import repositories, right? You need to inject these repositories into your core app. That really keeps your core app isolated. If you have questions about this part, I can answer it at the end of the presentation. So just to understand how it looks like, I'm using TypeScript because I think it's very natural to this process. So I'm defining a product repository interface, and that's very abstract. And my core app uses this repository. It doesn't care how it is implemented. And when you want to plug in your new data source, you just have to implement the actual repository, right? You implement it, and it is like a translation layer from your actual data source to the API that your core app expects. And luckily, again, React can really help us, or at least modern React can really help us with dependency injection, which means injecting your actual data source into your core app without breaking the rule of dependencies that points inwards. So here I can just use a React context. Inside the React content, I can define my repository, and then I can wrap any component that requires this data source with the associated provider, right? So I think that it's cool that React really have everything necessary in order to complete this cycle. From one side, you have custom hooks for interacting with view models, and from the other side, you have React context for dependency injection of data sources. So yes, React context can be used for dependency injection. I think that this is one of the major goals that React teams had in mind. So together with MVVM pattern that I showed and the concept of repositories, you get something that we can call technology agnostic frontend, which is stronger than framework agnostic frontend, right? Because it's completely isolated from the actual technology that you're using. Cool. So, well, by applying these patterns, and from my experience, we could show that our testability and reusability are significantly higher, dramatically higher. Right? It's very easy to test pure functions. It's very easy to use your core app when you want to support other platforms. So we actually could use the core app to support a mobile app or two different mobile apps and two different applications. One was very small that was written in React, and the other was heavier and it was written in Angular. So we could produce as much as versions of applications that we wanted by reusing this core app that is pure JavaScript or TypeScript. Right? You are not bounded to the framework. So now I would like to talk about the problem of splittability, a major problem that we often have with front end. And what I showed right now is not really helpful in solving that problem. Well, we often see this, as we said earlier, we often see this arbitrary division of responsibility between teams. And I'm sure that if you're a front-end developer, you probably was in some team that owns some components or some models. And it always feels not really natural, like you just arbitrarily choose stuff that your team supports or not. But actually, when it comes to resolving a user story, we always see teams having to coordinate and cooperate together because this is how it works, right? Resolving a user story affects this portion of code that belongs to multiple teams. And what we really wanted to do is to have a nicer flow of concerns, right? And so we have to think about how user stories are actually organized. And user stories are actually organized around business concerns, not around components, not around how you decided to build your app, right? It doesn't care about the structure of your app. It cares about the essence of your presentation domain. So you can split your presentation domain in a logical way, like defining like a very classical e-commerce app can be composed of a catalog, an ordering flow, a delivery flow, or support flow. And then you find out that user stories always emerges from these subdomains of your presentation domain. And if you have teams that own subdomains, they do not own any specific part of the software, they own subdomains, then you might find that resolving a user story is the work of a single team, and a single team can resolve the story end to end with little to no cooperation with other teams. And that's really good, not because we want people not to speak with each other, but because it makes the developer experience much better, and it's much faster to develop. So well, I just want to point out this is part of this is there is a wider discussion here about Conway's law and why it really relates to that, right? How can you promise that when you divide your teams according to subdomains, then they necessarily produce the software that is still splitted as you want? And not that with time, this software will be tangled again. And that's what Conway's law promises us, right? Organizations tend to build structures that mirror their own structure. So we can have this assurance that we will still get the software that we want. Of course, that you can take it to the extreme level and physically split your code by applying the micro front-end architecture, which is also very strong. And then you get a more isolated and higher, like increased autonomy for each team. You can also apply the BFF pattern, the backend for frontend. So it gives another layer of autonomy for teams, also on the API level. So my point here is that a solid ground for greater team's autonomy starts with aligning with business aspects. So you start to think about domain rather than technology, and then you get teams that are much more autonomous. Yeah. And this is where strategic DDD comes into picture. Strategic DDD is about taking the time gathering your domain experts. And when we talk about presentation domain, it means taking the time and gather your product owners as well and your UX designers and come up with this, what we call bounded context, right? This ambiguous language that everyone understands and can reason about. This is about building a common language for developers, for any stakeholder, to maintain software in a much clearer way. So, well, we can say that the front end is a technical implementation of bounded context. Like each subdomain of your presentation domain can be split into different subdomains, and each subdomain can be represented with a bounded context. So these are all terms that are taken from domain-driven design, and I think that it's time that we adopt them and utilize them in front-end development. Now that, well, autonomy can be resolved with strategic DDD. And well, the last part that I want to talk about is the expressibility part, the problem of writing code that speaks the language of your presentation domain, right? If we have a cart, or if we have some specific flow in our UI, we really want to be able to read it from the code, to understand it from the code. So this is where we can continue with our domain-driven design thinking. We have this bounded context that is really defines this language, right? And we can think about different different terminologies that people can speak about, right? But there is more into it. There is something that we call tactical DDD, which is actually fine-tuning your implementation. So with tactical DDD, it's not just that you build this language that everyone understands. You can actually model it by utilizing some great domain-driven design patterns. So you can split your terminology, and that's again about taking the time. There is no algorithm for that, right? You have to take the time and gather your domain expert and really brainstorm about it. And I've found from my experience that it's worth the time and investment because this is crucial for the success of your implementation. It can also drastically simplify your implementation because when you build software that matches some bounded context, you don't have to build it for other bounded context, right? Each team has its own language. They don't have to interact. And then you have simplified concepts that are really easy to reason about. So here I'm just showing this sketch where you divide your entities, your terminology, into aggregates, into aggregate roots, into entities and value objects. So entities are defined by their continuity and identity, while value objects are defined by their as properties of other entities. And well, that's a bit too deep for that. And so I think that together, now you don't have to adopt all what we talked about right now, of course. You can take part of this talk or get some inspiration about, well, you have the general inspiration of adopting backend architectures or patterns to your frontend. And you can also be more specific by applying a building technology agnostic frontend, and by utilizing domain-driven design to make your code readable and much more maintainable. So just this very small summary of what we were talking about. We say that modern UI are complex, and we have to treat our presentation logic as a whole new domain and tackle that complexity in a serious way. So technology agnostic frontends can enhance the stability and reusability, and we showed an example using the MVVM and repositories. We also saw that modern UI frameworks, together with TypeScript, are very suited to implement such ideas. And this is from my experience that really works, and that's great. And we also showed the deeper level when you come to implement your actual core app, and you can think about building teams that around business aspects rather than around technical concerns, and that will enhance the team's autonomy, and autonomy is important for everyone. And finally, you can fine-tune your implementation, apply tactical DDD to make your code more maintainable and aligned with the domain model. Yeah. So that's it. Thank you very much, and I would love to hear some questions. Any questions? Oh, yeah, that was clear. Thank you.
A ver o output por aqui, que estás a ver que está a bater nos 0, nos 2, às vezes vai aos 6, dependendo com o entusiasmo com que eles falam. Mas está a chegar aqui. Mandar isto para aqui. E estou a enviar, mas a partir do momento em que eles estão ali muito pertinho, estás a ver? Isto é sensibilidade a mais. Uma pessoa tem que estar dentro do. Eu sei que é baixinho, ou é menos um bocado, mas estamos. Portanto, agora deverás estar a receber o sinal em pré. Portanto, estás a receber o sinal em pré, mas estás a receber um sinal saudável, vais receber sempre isto. Ou seja, mas também a gente tem conseguido trocar, ou seja, não temos ligado dois microfones em simultâneo, estás a perceber? Que era o risco que corríamos, era estar a trocar um speaker para o outro e como estão os dois ligados, ele a ligar as tantas está-me a fazer perguntas e tu já ias estar a ouvir no stream. Isso não convém, mas a gente como tem trocado com alguma facilidade o stream. Mas agora já tens que estar a ouvir isto e ninguém está a ouvir na sala e está cortado para a sala. E já está a ir o áudio para aí. Portanto, 1, 2, 1, 2, 1, 2, 1, 2, hey, hey, 1, 2. Estás a passar para o stream, ótimo. Sim, bom dia, gente. Portanto, isto não convém, não é?
Está só a ouvir em casa.
Exatamente, fantástico.
Yeah.
Já está, já está. Já está. Já. Portanto, cá estamos outra vez. Não, isto estava-lhe encostado ao canto da boca. Isto não precisa estar encostado ao canto da boca, portanto era físico a tocar no microfone e não o...
Sim, isso depois já não.
Porque ele, quando olhava para o ecrã, afastava o microfone e estava tudo bem, mas depois olhava para a frente outra vez e encostava lá a boca. Pronto. Portanto, estamos a ter sinal outra vez. Certo?
Estás a ser ouvido lá em casa?
Não.
Não? Ok, estás só na frente.
Não, não, quer dizer, estou na frente e depende da autorização que tu tiveres no stream, mas eu agora estou com a via aberta.
No streaming está sempre aberto.
Pronto,
Se
então,
tu envias
Does this work? Yeah, you can hear me, right? Cool. All right, let me just wait 30 more seconds for people to come in. Is it possible to dim the lights a little bit? Okay, well, I don't know. Well, this should be okay, right? Can you see that okay? It's fine? Okay. Well, let's get started. Hello, everyone. My name is Meta Tamel. I am a developer advocate at Google. I'm based in London. I love visiting countries like Portugal because the weather is always better, food is better, and people are friendlier. So I'm glad to be here, especially after 2 years of pandemic where I was speaking online to, it felt like to a wall. So it's good to see everyone here. And today I'm going to talk about serverless beyond functions. And what I mean by this is that when we think about serverless, we usually think about functions like AWS Lambda or Google Cloud Functions. And actually, it's much more than that. So what I want to do in this talk is that first I want to do a little bit of history of serverless, like go through the different phases of serverless, how it started, how it evolved, and where we are today. And then towards the end, I want to show you some patterns in the serverless that we have today that kind of works, and with some demos as well. So hopefully it will be useful to you if you are using serverless or if you're not using. Either way, hopefully it will be useful. The slides are already on. So if you want the slides, that's the link. The demos I'm going to show, they're going to be on GitHub. And I'm going to share the links at the end of the presentation as well. So anything you see today, you have access to it at the end of the talk. And if you have questions, please raise your hand and ask anytime. That's the beauty of having in-person conferences. We can have an interactive session, so feel free to do that, okay? All right. Now, serverless, what is it? I don't think I should explain what serverless is nowadays, but just to recap, when we are talking about a serverless service, we can think about it in two different ways. We can think about how we are running our code, so I call that the operational model. And when we are saying a service is serverless, we basically say there's no infrastructure management, meaning there's no servers to set up, there's no machines to configure, so that is done by someone else, so it's not your problem anymore. There's base level security taken care for you, so you don't have to worry about securing the ports or securing, the basic security basically is given. And for me, one of the most important things about serverless is you pay for what you use, right? So it's not like a virtual machine that runs all the time and no matter what, you just pay for it. Instead, in serverless services, you only pay for what's being used. And if nobody uses it, it scales down to zero, you don't pay nothing, right? So that's how you run your code in a serverless way. You can also think about it in how you write services. So that I call that the programming model. And in this model, we are talking about services, so it's service-based. And usually, these services are event-driven. So some event triggers your service. This is usually HTTP, but it can be event-based as well. And I'm going to show some examples of this later. And usually, these services are stateless. The reason for this is that if you have state in your services, then it becomes quite difficult to scale. Because then you need to worry about how do you route users to the same service because it has a state. So usually what you do is that you make your service stateless, you externalize the state. That way, when you need the state, you grab it from externally, but it's not part of your service. So that's what I mean roughly when I talk about serverless. Now, when we look at the serverless history, I think there's 4 distinct phases. The first phase was serverless before it was called serverless. Second, simple functions. That's what we mostly think about serverless when we are talking about serverless. Then the second phase was containers and serverless maturity, because you will see that with simple functions, what you can do is limited. And then we have these things called containers. And there was this parallel universe that existed for a while. But now, in the second phase, they kind of started coming together. So we had containers coming into serverless space, and we also started seeing serverless becoming more mature. And finally, today, we see the expansion and integration of serverless. So everything that can run serverlessly, they pretty much do. And then we also started seeing serverless integrating with non-serverless things. And I'm going to talk about more on this later. So let's go through these phases and let's see what we had and let's see what we have today. And then hopefully it will make sense in the end. All right, so serverless before it was called serverless. Let's look at that. Anyone recognizes this logo? Anyone? Any guesses? What? No. Well, this is App Engine, and this was launched back in 2008, so it's been already more than 12, well, how many years? A lot of years, basically 14 years. And the goal of App Engine was to make it easy for developers to build, manage, and scale web applications. You would just write some Python, and there was a command line tool. You would deploy the Python, and that was it. Like, the things were basically fully managed for you. You would have this web application where you didn't have to set up servers, you didn't have to worry about load balancers, there was no database to set up and manage. App Engine came with default load balancing and default data store. So in my mind, this was kind of serverless, right? But we didn't call it serverless, we called it fully managed because some of the things were missing. For example, the payment model was not quite serverless. But this kind of started serverless in my mind. So when we look at the state in this fully managed world, this paved the way for the vision of serverless. So people started seeing that it is actually possible to run a service without having to worry about the underlying infrastructure. But it was very limited. So when you look at the original App Engine, it was Python, and later we added Java. But it was just those two languages, and it was a subset of those languages. So you couldn't even do everything you could do in Python or Java. So it was a very subset, it was a very limited versions of those languages. It was mostly HTTP based, not mostly, but only HTTP based. So it was only for web applications. And it was a very limited ecosystem. So if you wanted to use this in the Google Cloud, no, it wasn't even Google Cloud, in the Google ecosystem, you could do it, but there was no ecosystem around it. So imagine you're coming from open source, you're using all this Apache stuff in 2008, and then all of a sudden we tell you we have this new App Engine, come and use it. It was not easy for people to do because people were scared of vendor lock-in, and rightly so, right? You can't just depend on one company for all your infrastructure. And at the time, people were running on-prem virtual machines. So when you have on-prem virtual machines and you tell those people, forget about these, all the investment that you did, and just switch to this fully managed App Engine, that was a huge step, right? So, and there was nothing in the middle. There was no middle ground where people could gradually go to the fully managed, right? So it was either on-prem virtual machines or this thing that runs somewhere and it's fully managed, but there was nothing in the middle. So people didn't want to do that jump that quickly. And that's why Google Cloud was built, and that's why we have all these other services within Google Cloud to kind of fill that gap, basically. So that was like serverless before serverless. Then we had the first phase of serverless, which basically is simple functions. And when you look at this phase, this started in 2014 with AWS Lambda, and that's when we started hearing about serverless. And then it was soon followed by Google Cloud Functions and Azure Functions in 2016. But the idea here is that you just define a simple function. Here's a Node.js function that handles some HTTP request and response, and then you respond with whatever you want, and that's it, right? So you just define this function, deploy it, and that's it. Like, you don't have to worry about machines. You don't have to worry about configuration or anything like that. By default, this just worked. But you had to pay attention to this table. This table is probably already out of date, by the way, but it shows you what languages are supported on what cloud platform, and not only that, what versions of those languages. So whenever you're building something, you had to basically say, okay, I'm using C#, can can I do it on Google Cloud? Well, it's 3.1, and now C# is 6, right? So you can't do it. With Java as well, it's only up to 11. I think this might be updated recently. But basically, there still is this table that you need to pay attention to. You can't just run any language and any version of that language. And when you look at these functions, they were mainly HTTP driven. So usually it was the HTTP or HTTPS that triggers your function. And on Google Cloud, the first generation of cloud functions, we also had some other triggers. For example, you could save a file to cloud storage, and that could trigger an event, or you could push a message to a PubSub topic, and that could trigger an event. So these were handful triggers that we provided, but they were very limited. Like you couldn't trigger your function in many ways. It was only like 4 or 5 different ways. And when you look at the resources that you have around these functions, they were also limited. Again, giving an example from Cloud Functions Generation 1, it was HTTP based, so that was the main protocol, and you couldn't do anything in the background. You had to do everything within the HTTP request thread. The processing time was limited, so by default you get 1 minute to do your work, and then you can change that up to 9 minutes. So it was for small tasks that you can reply back quickly, but not for batch processing, for example, where it can take hours or days. And the memory and CPU you get was also limited, like 8 gigs and 2 CPUs. So for small things, it worked, but for anything bigger, you were out of luck, basically. By the way, I'm giving most of these examples from Google Cloud because that's what I know, but this is true for other cloud providers as well. And as we go along, I'll try to give examples from them as well. But these points, they apply to pretty much all the cloud providers. And we also had this cold start problem. The concurrency was 1, meaning when a request came in, you had to handle that in a cloud function. So we had to create the cloud function. When the second request came in, you had to create another cloud function. So it was 1-to-1. And because of this, if your cloud function wasn't starting up quickly, the users would notice that, right? Because every time they made a request, that would they would have to wait a little bit for the function to be initialized, run, and respond back. So this cold start was there for a while until we solved it later. And then once you start having multiple functions, then you need to start thinking about how do you want to group them together, right? First of all, on AWS, you couldn't have a function, a public endpoint function. So you couldn't have a function with a public endpoint. So what you had to do was you had to deploy your Lambda, and then you had to use the API gateway on AWS to make it public, so to create a public endpoint for that. On Google Cloud and Azure, I think you can have public endpoints from the beginning. But then, if you are building an API, for example, usually you need multiple functions, because functions, by default, they handle one path, right? And in an API, you have multiple paths. So how do you do that? So what you do is you have multiple functions, each handling a single path, and then you group them together using some kind of an API gateway. So on AWS, API gateway was introduced early on because of the limitation of functions not having public endpoints. But then on Google and Azure, you also had API gateway and API management. Basically, these things, they all helped to group your HTTP-based functions together into an API. By the way, the AWS changed this now, so that when you deploy an AWS Lambda function, you can have a public endpoint, so you don't have to use API gateway anymore. But this was a very recent change, I think this year. All right, so in this first phase of serverless, we had limited languages and versions, so you couldn't run anything you want. We had limited triggers, so it was mainly HTTP based with a handful of other storage or PubSub kind of triggers, but it was quite limited. We had limited execution model, time and resources, so the function had to be small, it had to answer quickly, it had limited memory and CPU. We had this cold start problem because of one-to-one concurrency. And I didn't mention this, but also there was not much local development, right? So if you wanted to build a function locally and test it out locally, there wasn't much support for that. So you had to kind of deploy your function in the cloud and see and call it and see if it works. And we had some grouping for the HTTP functions, but there was nothing complicated. It was just basically a way to group them, but you couldn't do more complicated orchestrations or anything like that. So this was a good beginning, but it was very limited for the things that you wanted to do. So it was for very small microservices that did very quick things, but that was pretty much it. Now, in the next phase of serverless, we started seeing containers coming into the picture. So let's talk about that. Now, if you remember, there was a time where we had two parallel worlds. On one side, we had this serverless stuff coming up with functions. And what serverless enabled us to do is that it allowed us to go fast because we don't have to manage any clusters or machines. It's just the code that you need to think about. But at the same time, we started having containers. And containers allowed us to create a context that we can replicate everywhere, right? So you define any language, you basically use any language you want, you can use any library you want, and you define this context in the form of a Docker file, basically. And then with that context, you can run the context locally on your machine, or you can run it in the cloud as well, and you can rely on the context to be the same. So we had things like Kubernetes and Knative and that basically what people use to run containers. And we had these two worlds against each other, right? Serverless for velocity, but then you had containers for flexibility of choosing whatever language you want. But there was no overlap, right? So if you wanted to use containers, you had to basically learn about Kubernetes, which is not easy. I mean, if you look into Kubernetes, there's a lot of concepts that you need to learn about. And then you need to think about a cluster, a Kubernetes cluster, right? So you need to set that up. You need to maintain that. I know there's Kubernetes engines on Google Cloud and other clouds that makes it easier, but you still need to think about that cluster, right? But thankfully, there are tools, well, services that basically try to make running containers as if they're like serverless functions. So these services like Cloud Run, for example, on Google Cloud, or AWS as App Runner, Fargate, Lambda, or container instances on Azure, they are different. They're not one-to-one the same, but all they're trying to do is, make it easy so that for you to run containers in a serverless way, so that you don't have to worry about the underlying cluster or infrastructure. And when you look at Cloud Run, it's based on a project called Knative. It's an open source project that basically brought serverless containers on Kubernetes. So if you want to run containers on Kubernetes and not worry so much about the cluster, you can use Knative. And then Cloud Run is the managed version of that on Google Cloud. So when you use Cloud Run, there's not even a cluster, basically. You don't see a cluster. You just say, here's my container, deploy your container, and it's deployed, and it's auto-scaled like a function. It's priced like a function. So if no one uses your container, you don't pay for anything. So it's basically like a function, except it's a container, which means that you can define what the container is. And you can basically define your own runtime. You don't have to depend on the runtime of the function that you are using. So that's the big difference between serverless functions and serverless containers. But this container, it cannot be anything, right? Because, I mean, as you know, in containers, you can pretty much run any kind of code. But these containers, they need to basically adhere to some container contract. If you look at, again, on Cloud Run, this has to be an HTTP-based container. So you need to listen on 000 and on port variable, which is port 8080. This HTTP server has to start within 4 minutes. So it cannot be like this huge application server that we used to have back in the day that would start in like 10 minutes. It can't be that. The request time, so how soon it needs to respond, is now 5 minutes instead of 1 minute to functions. And you can increase it up to 60 minutes. So as you can see, the request time is increasing now. So you can run things for like an hour, which is pretty decent. It's still stateless containers for auto-scaling purposes. but you can only do things within the request. So within the request thread, you can do computation, but you cannot have background threads still. And when you look at the resources, you have more resources now, like up to 4 CPUs and 8 gigs, so things are getting bigger and more resources. More concurrency, and I'm going to talk about this in the next slide. And they're auto-scaled from 1 to 1,000 containers. And one biggest difference was that, since this is an HTTP server, it can listen on multiple paths. So if you want to build an API, you can do it in a single container instead of having to deploy multiple functions and having to have API gateway. So that's also one difference between containers and functions. And when you look at concurrency, remember in generation 1 of Cloud Functions, it was 1-to-1, and we had cold start issues. But in generation 2, and also in Cloud Run, you have concurrency 80, meaning you can handle 80 requests at the same time in a single container. So what this means is that this cold start problem is much improved. It's not gone away, because for the first request, you still need to create the container, so it's still there. But the fact that a single container can handle multiple requests makes this cold start problem less likely, okay? So that's number one. And the number two is that there's also this notion of minimal instances in Cloud Run. And this is set to 0, meaning if no one uses your Cloud Run, it scales down to 0. But if you want to set this to 1, that will run as one container at all times, whether someone uses or not, right? So with that, with 80 concurrency plus some minimal instances always running, you don't run into cold start problems, most of the time. It can still happen, but most of the time, you don't run into it. And at this stage, we also started seeing some improvements on local development. So since we are running containers, we can run Docker locally and see how it works. We can use build packs, which is an open source project to convert your source code into containers without having to write the Docker file. On Google, there's something called Functions Framework that allows you to run Google Cloud Functions locally if you use this framework. And there are emulators for different services, like for PubSub and Data Store, for example, so that if you want to do some testing, you can use these emulators locally. And also, there's local stack on AWS that tries to mock all of the AWS services so that you don't have to actually call the actual service in the cloud. And I'm sure there's more stuff here, but I'm just giving you an example of basically some tools and things that came into play that made local development much more sustainable at this stage. And then I think I mentioned all of this. So at this stage, we had things running longer with bigger machines, and then we had build packs to take our code and make it into a container, so it wasn't a big deal to run containers anymore. And also, we started seeing richer protocols, right? I mean, so far, we only had HTTP-based services, but with containers, we could use WebSockets, so more real-time connectivity. We could do server-sent events, and we could also use gRPC. gRPC, it's an open-source encoding protocol that makes the communication between client and server much more efficient compared to JSON. So you could use that as well. So as you can see, the protocols are getting more richer, more real-time, and more efficient at this stage. And we could also start doing some basic orchestration. So let's say you want to deploy a service, it's serverless service, but you want to call it on a certain day at a certain time, right? You could use services like Cloud Scheduler on Google Cloud to configure that. And on AWS and Azure, it's called Cloud Watch and Scheduler. But basically, this allows you to do a little bit of orchestration of your service. Or if you want to do a task-based orchestration, you can use something called Cloud Tasks on Google Cloud, where you capture what your task is, put it in a queue, and then that queue calls your service at the rate that you define. And again, on AWS and Azure, there's other services like SQS and Service Bus to do this kind of stuff. But what this enables us to do is that it's basically, we have our code running serverlessly, but we also had these basic orchestration services to call our service in either based on a schedule or based on some kind of task-based queue. All right, so what was the state at this? What was the state of serverless at this phase? Now we can use any language and version with containers. The triggers are limited. It's mostly HTTP based and a handful of triggers. The execution model time and resources are increasing, so we have bigger resources and longer time to do things within our serverless functions or containers. Cold start is not a problem anymore for the most part, even though it can still happen, but not as much. Local development is not an issue. And yeah, we had the grouping before with HTTP, with API gateway, but we also have some options for orchestration with schedulers and tasks and things like that. And this takes us to the next phase of serverless, where we started seeing expansion and integration of serverless in pretty much everything. And this is the phase that we are in, I think. So here, so once you start having multiple services or containers running serverlessly, at some point you need to figure out how do you organize them and how do they talk to each other, right? And there's basically, well, there's 3 different ways of doing this. One way that I'm not showing here is that you could have your services call each other directly. So you have service A calls service B calls service C. This approach is not here because it's not a good approach. The reason being is that, you know, if service A needs to know about service B, you need to kind of get that information into service A. And then every time you need to change something about service B, then you need to think about service A as well. So it's not a good approach to have this direct calls between services. Now, instead of doing that, what you could do is you could use events for communication. So in this event-based model, also known as choreography, you have an event bus in the middle, and the services, when they finish their work, they just send an event to that event bus. So service A finishes its work, it says, you know, finish work A, and that will go to the event bus. And actually, this diagram is a little bit wrong because it implies that, you know, service A sends the event to service B. It doesn't really send it to service B. It sends it to the event bus, and the event bus routes that. So whoever is interested in that event. So service A's event, maybe service B is interested, it will get that event, and it will act on it. And when it's finished, it will send another event. So in this event-driven approach, you have services that are loosely coupled. They don't really know about each other, and they don't care about each other. They just communicate indirectly with events. So that's the good thing about event-driven systems. But the bad thing about event-driven systems is that once you have a lot of services, let's say, you know, 20, 30, or 100 services, then it becomes quite difficult to trace what's happening in your system. You know, if something doesn't work, you don't know immediately which service didn't send the message, or maybe which service didn't process the message, right? So even though it gives you a lot of flexibility to, you know, deploy services and update them in a loosely coupled way, you'll lose a little bit of monitoring and traceability when you're using events. Now, on the other hand, what you can do is you can also use what's called an orchestrator, an external service that orchestrates the call in the order that you define. So here, Google has something called workflows, for example. Here you define at workflows how your services should be called, and an orchestrator will call those services in the order that you defined. Now, the good thing about this is that now you have a central place to define how things should work, and then things also become really easy to monitor because since orchestrator knows how things should work, if something doesn't work, let's say it makes a call to service B, you will see that immediately that service B didn't return the call. So it becomes easier to monitor. So you have these 2 approaches like choreography or orchestration, and depending on what you want to do, one is better than the other usually. So for loosely coupled architectures, this is better. But for more structured architectures, orchestration is better. And the beauty of orchestration is that your services are still independent, so they are still independently deployed, but you kind of bring them together into what I call a temporary monolith, basically using an orchestrator. And when you look at cloud services, on Google Cloud, there's EventArc and PubSub for event-driven architectures. On AWS, there's SNS, Event Bridge. On Azure, there's Event Grid, Event Hubs. So there's a lot of option here. So pick and choose, depending on where you're running. Pick and choose the service that's available to you. And what EventArc does, Google's eventing service, is that EventArc basically increases the triggers to your functions and containers. So you not only get your function or container triggered by Google Cloud sources, but have external third-party services also calling your serverless services. So this increases your triggers from just a handful to basically hundreds, maybe even more services that can call your service. And when you look at orchestration, as I mentioned, workflows is what Google has for orchestration. So imagine you have this flowchart where you have an ordering system. You can take this flowchart and you can actually convert it into a workflow definition, and workflow will make these calls in the order that you define. And on AWS, there's step functions for this, and then on Azure, there's durable functions for orchestrating functions, but then there's also logic apps to orchestrate functions and also external services and many, many other things. So again, the point here is that if you want to do orchestration, there's services in each cloud to do that, so you don't have to do this yourself. And when we look at workflows, workflows allows you to orchestrate and integrate services. So if your code is running on Cloud Run or functions, you can take that and put it into your orchestration. If you have Google APIs that you want to call, you can put that into your orchestration. And you can even include external APIs in your orchestration. So it allows you to bring all of those together into an orchestration that you can define. And actually, let me show you an example of this. Let's say I want to chain some services together. So I have service A, service B, service C, service D running in different places, and I want to bring them into an orchestration. How do you do that? Well, I would use workflow, and my services, I don't know if you can see this, but my services, my first function, it's a cloud function that's called random gen. It generates a random number. So I deploy that. It's a Python function. Then the second function is another cloud function called multiply. So given some numbers, it multiplies them. So it's something very simple. And then the third function, it's an external function from Math.js. So in Math.js has an API where you can pass in an expression. And this expression is basically a mathematical expression. And it gives you the result back. So in this case, we are using the log function from Math.js. And then the fourth service is it's a Cloud Run service. So it's a container that's called floor that takes the floor of a number. So if you give it a number, say like 6.86, it will give you 6, basically. So as you can see, we have two cloud functions in Google Cloud, one external function running somewhere else, and then one Cloud Run container that's running a container service, basically. So to bring this together, what you need to do is you create a workflow definition file. This is in YAML, but it can be in JSON as well. And then you define your steps. What should happen in this orchestration? Now, in the first step, we called it random gen function. We are making an HTTP GET call to the cloud function. So this call is made by workflows, and the result will be captured in random gen result, right? So that's the result that will come back from the service. Now, in the next step, we are making an HTTP post call, and the URL is, again, another cloud function, but the body has an input from the previous result. So we get the result from here, and we parse the body of that, and we look for random. That's where the number will be, and we'll provide that as input, and the result will be captured as multiply result. Then the third one is the log function, and you can see that here we are making a call to Math.js, so external function, and we are passing an expression. This is a query expression, and we are, again, using the result from previous step, and then parse the body and the multiplied, and look for the multiplied, and then pass that as an input to the log function. And finally, the last one is a call to Cloud Run service, which is running a container, but it's an authenticated service, meaning it's a private service, so that's why I have this authentication here. And then the input is again from the previous result. So we are basically making the calls, capturing the result, and passing the result into the next step. So that's how you define it, and then you deploy to Google Cloud, and then I already have it here. So if I look at service chaining, if I look at source, you can see this is the same source I show you, but the nice thing is that you also get a visualization. It shows you how things should be called. So it's very simple, just a chain. And if I want to execute, I'll just come here. You can provide an input, but in this case, we don't have an input. The first function generates the number. So I will just execute this. And then now the whole chain is being called. And you see that there's the input, but then once we finish, we should see an output, which will be basically a number. So you can see that the output is a body with 4. So that's the output. And I'm also outputting some HTTP codes and headers and things like that. So that's how you can kind of do orchestrations I mean, this is a very simple example, but you can imagine the kind of things that you can do here with workflows. Now, what I also seen is that, once you have event-driven systems and once you have orchestrations, you don't have to actually choose one or the other. And what usually happens is that I see people kind of combining them together as it makes sense. For example, in this example, I want to build an image processing pipeline, right? So I want users to upload some images to a cloud storage bucket. And then once that image is uploaded, I want a number of functions to process that image. Now I have 4 functions. The first function is a filter function that will filter the images, whether they are safe or not, using machine learning, okay? So if the image is safe, then it will pass it to the labeler function that will, again, use machine learning to extract the labels out of the image. And then it will call the resizer function that will resize the image to a size that we determine. And then finally, the watermarker function will get the labels from this function, and it will get the resize image from this function, and it will create this new image that has the image and the labels on top as a watermark, and it will save it to the output bucket. Now, when you look at this, I put these 4 functions into an orchestration. And the reason for this is that, these functions, they need to be called in a certain order, right? First, it has to be filter, then it has to be labeler. It doesn't make sense for them to be loosely coupled, or the order doesn't change. It always has to go this way. And actually, the input of one feeds to the output of one feeds to the input of the other, right? So because of that tight coupling in these functions, it makes sense to make them into an orchestration. And that's what I did here. But then to call this orchestration, it doesn't have to be a direct call, right? It doesn't have to be tightly coupled. Instead, I used an event-driven approach here. So I use event arc to, whenever user uploads a picture, it will basically generate an event. That event will go to workflows, and then workflows will execute our chain, right? So if you want to look at this, it's on GitHub. Again, you can get the links from my presentation. Just to show you, maybe I'll show you in here the workflow, how it looks. So if you go back, image processing, then look at source. So I don't know if you can see this, probably not. So let's go back. Yeah, so this is the workflow. It will receive an event, then we'll log the event, then from the event we extract the information about the file, the name and the bucket information. Then basically we just call the filter function, and the filter URL will be replaced, but basically we are calling the filter function and get a response. And then we check the safety. So the response has a safe flag in it, so we check if the safe is true. So you can see I can do conditionals within my orchestration, so I don't have to do that in the code. And then if it's safe, we go to the next step, but if it's not safe, we end our orchestration. So then we call label to get the labels, then we call the resize to get the resize image, and finally the watermark is called with the resize image information and also the labels, right? And then the final result is just HTTP code from all the functions. I mean, you can return whatever you want, but here I'm just returning the HTTP codes. So just to see that it works, and I think I still have 5 minutes or so. So image processing, well, I need to upload an image just to see that it will trigger. And then so I have a bucket here, input. I think it's this one. Well, it's one of them. Let's try this one. Okay, I'm not too sure, but so let's upload this picture. All right, so this will trigger the event, and then this event will go to, and just to be on the safe side, where did I upload? So I uploaded here, right? Let's upload to the other one too, because I'm not sure which one. I think it might be this one, to be honest. Let's upload the same picture here. All right, so if that triggered, we should go to workflows. And if you look at image processing, you see that there's an execution that's running. And if we click on that, the input is an event, so with the bucket and file information, and it already finished. So if you look at here, the execution is succeeded. The output is just filter, label, resize, watermark 200, meaning they all return correctly. And just to look at the image, output files. So if you look at here, then we see some images, and I think this is the one that I uploaded. So this is the first, you see that this is the labels, this is the resize image, and this is the resize and watermark image. So if I click and look, all right. Well, there you go. So the picture with water, cloud, sky, so it picks the top 3 labels and just puts as a watermark on top of the image. So you see how you can combine event-driven and orchestration as it makes sense. Now, to finish it off, I also started seeing where we combine serverless with servers. So let's imagine, for example, you want to run a long-running operation. Like let's say you want to calculate a prime number that can run, for days, weeks, or even years, right? For that, you cannot use serverless because serverless has limitations, like 1 hour or maybe a little bit more, but it has limitations. So what you can do is that you can actually create a VM, run a container on that VM as long as you want, and then you can configure that VM to have as many resources as you want. And then in the end, tear down the VM and get the result. We will get the result and tear it down, right? And you can do all of this, again, using orchestration. So you can use workflows to automate this, creating the VM, running the code, getting the result, and shutting down the VM. So I have this example here. I'm not going to show it here right now. But basically, what this enables you to do is that you just run an orchestration, just run this for 2 days, and it will just do it for you. In the end, you just get a result back. But behind the scenes, you are using servers. So it's combining serverless with what I call serverful, as it makes sense. And there's also a new thing called Cloud Run Jobs. So again, so far, we've been dealing mostly with HTTP-triggered services. But let's say you want to do background tasks on a schedule, right? For that, now there's something called Cloud Run Jobs that enables you to run a container that's not triggered by HTTP. It just gets called. It does its job, and then when it's done, it will just be finished. And yeah, so if you want to do like what I call the run to completion containers, there's also options for that now with Cloud Run Jobs, and also on AWS, I think they have something like that as well. All right, I think I'm almost out of time, but the point is, I think most of the stuff that we talked about, they're now possible with serverless. And even if it's not possible, even if you need the customization and extra resources of a virtual machine, you can still use serverless orchestration to manage that so that you don't have to make developers deal with infrastructure directly. It can all be automated in a serverless way. So I think we are in a much better shape today. And then we didn't even talk about these other serverless/managed data and services, because we mostly talked about running your code. But once you have your code running in a serverless way, you should also think about, okay, what about my data layer? You know, if I want to run a NoSQL database, there are serverless options. So you don't need to set that up or run yourself. Or if you want to use cache, there is things like memory store and other services that allows you to have a cache where you don't need to worry about services or instances or scaling and things like that. So keep that in mind as you're building services. Like it's easy to choose a wrong service and just have to manage all this stuff. Always look for the serverless option, and if you cannot find it, maybe then start thinking about how to do it in a non-serverless way, but can you make it easy using the serverless orchestration or eventing or something like that. So I think I'm almost out of time, but this is the takeaway from my talk. I think serverless is now the default way of running code in the cloud. Use it if you can. If not, try to automate things using serverless. The presentation is on speaker deck. And if you go to my presentation, you will see the links for GitHub as well. Yeah, so thanks very much for listening, and I'll just wait if you have any questions. Thanks very much. So any questions? Yes, let's wait for the microphone.
Hi, thank you so much for the presentation. I'd like to do a couple of questions about, specifically about your examples that you showed from your orchestrator before. So I saw that you had authentication in one of the orchestration steps. I wanted to ask, how does it know like what credentials to use? Does it go to another Google Cloud Platform service to get the credentials? This is kind of a far-fetched example maybe, but like, can you combine different URLs from different cloud providers, or is this a Google Cloud Platform exclusive service that you can only use with Google Cloud Platform URLs?
Okay, yeah. So for the first question, how does it know how to authenticate, basically? Well, when you deploy a workflow, you deploy with a service account. And that service account has roles. And then from those roles, you basically are allowed to do certain things or not. So in this example, we were calling Cloud Run. So that service account has to have Cloud Run invoker role. And if you have that, then you will be able to make that call. So that's that. Now, the second question was, can you combine URLs from different cloud providers? Yes, you can. Workflows can call, well, any URL you can call from Google Cloud, you can include in workflows. So it has to be accessible from Google Cloud. But as long as it's accessible, yeah, you can include it in your orchestration. It doesn't discriminate against any cloud provider or any URL as long as it can access to it. Yeah. Any other questions? Yes.
Hello, thank you for the opportunity.
Yeah.
I would like to ask if we could use stateless, serverless for something like streaming video, or does it run into the limitation of 1 hour?
Well, I mean, yeah, right now you have this 1 hour limitation on Cloud Run. So if you can process things within 1 hour, it will work. But anything more than that, you have to find a way to kind of cut it to 1 hour and then maybe continue in later, like another Cloud Run instance.
Would it still scale automatically if multiple users use the same endpoint at the same time?
Yeah, I mean, Cloud Run auto scales by HTTP calls. So the more HTTP calls you get in, the more it scales up to a limit that you define. So there's this max instances limit. And I think it goes up to 1,000. So you can set it up to 1,000. So it can scale up to 1,000 containers if you want. If you need to scale even more than that, then you need to open a ticket to increase those limitations. So there are soft limitations, but they do exist. Yeah. One more question?
What do you think are the next steps for serverless for stage 4?
Yes. Yeah. What are the next steps? I think basically everything by default will kind of run in a serverless kind of operational model, right? So if you have databases, by default, you would expect them to kind of run in a serverless way, like meaning you don't have to provision them, you don't have to do capacity planning, you don't have to pay for the full price all the time. So maybe you would pay for the data that you have in there or the way you access it. So that model that we are used to in running our code, I think it will infiltrate to other things like data layer and other services. And that's what people will basically take it as granted. So serverless will be the default way of running things. That's my opinion. Any last questions? Yes? No? Okay. Well, thanks very much for coming. And if you want to talk more, I'm here for the rest of the conference. So yeah, thanks very much.
That's right. Okay, yeah. Oh, that's awesome. Thank you. Okay, so this is the talk I'm doing now. If you'd looked earlier today, it would have been a different talk because I was planning to talk about something else, but in the end, it just wasn't working. It was a brand new talk, and I'd been asked to do it because if you may have seen the agenda earlier, I was going to be doing a talk with Grace Jensen about security in biology, and so you can imagine it all went terribly wrong. And so we're here talking about something that is still very important and very useful. So I'm going to talk about this thing. Who's heard of Log4Shell? Yes. And I'm going to take you through that, what it is, and we'll do a little demo in the middle, and then we'll talk about the consequences and other stuff, and maybe you get to ask some questions. Right. So, okay. The reason that Log4Shell is here is because I work with an amazing guy called Ak Sharma, and he is a cyber researcher, journalist, and he always finds amazing vulnerabilities because that's what we do. And I said to him, why can't you find some Java problems? You're always doing Node stuff. All right, so that was on this day. Of course, you know, the next day we have Log4Shell, and suddenly I get my wish. And this thing turns up, and it grows. There's all sorts of information starting to float around. It gets on the TV. Java vulnerability gets on the TV, and it gets to the important people, and then it gets to the leaders of the political space,
And it just keeps growing. Log4Shell may be the worst ever vulnerability, and that's not even saying a Java vulnerability. At the time, and I think we can still claim that given all the circumstances, it is still the most obviously exploitable, high impact vulnerability that we've ever had. There may be other ones out there that we don't know about, but this one, this is easy. And I'll show you how easy it is when we get down to the demo. And it got to this state of being horrific, and we're all going, what are we going to do about it? And then it got worse because people began to understand a bit more about how it was working, and they learned how to change data. So one of the things about Log4Shell that you have to take away is that Log4Shell is about exploiting the data that your application receives and the application logs. And I talk to people and they go, well, I don't have an internet-facing application, so it's okay. And I go, it's got nothing to do with the internet, it's to do with the data. So if you read a database and you log the records in that database, even if the application doing that isn't on the internet, if that database has the right type of data in, then they've got access to your system. And so what was happening here was that people were literally playing around with the names of their phones and the names of their Teslas to put in the bad characters, which we'll talk about later, so that they could actually trigger these vulnerabilities. Right? That's how easy it became. So wrong thing in the wrong place, wrong vulnerability, thing we haven't seen for a very long time. Before this, we had struts. You may remember struts 2 back in 2017, I think it was, maybe earlier than that. Now, one thing to know about Log4Shell is that it turns out that the vulnerability isn't a new one. It turns out that the problem has been around since 2014. So it's not even one of these zero-day things you may hear about where somebody finds it, gets reported, people start exploiting it. No, the world has been telling the Java community since 2014 about some of the fundamental weaknesses in Log4j that could be exploited. So we have a fix for something that's quite a few years old. Okay, so I'm going to go through some of this. Depending on where we go and what questions get asked, we may cut up, we may do things faster or slower. We're going to talk about the whole space of Java exploits. I'm going to talk about mechanics specifically of Log4Shell, give you a demo, and then talk a bit more about the consequences and the things that you need to learn. Okay, so why Log4Shell? Well, Log4Shell lets bad guys achieve something that they really, really want to do. It's the primary driver for Log4Shell. Is the main objective is what's called arbitrary remote code execution. You may hear RCE or ARCE, and that literally says this is a gateway that allows the bad guys to run whatever code they want. Absolutely whatever they want to do. That's their main objective. Right? And whatever they do, steal your data, change your data, but that's the primary thing, is full access to your system. Imagine the conceptual thing is they can get access, they can log on, get a console on your system. That's what they're after, because obviously then they can do whatever they want. If they can't achieve that, arbitrary remote code execution, there are some other things they might just be able to get. They may not be able to run arbitrary code, they may be able to just run the code that you've got installed, the tools you've got installed. And even if they can't do that, maybe they'll try and steal your data or change your data. Every point of that access, every part of the system that's been compromised, there's always a value. It's just a matter of how much value it is. And unfortunately, Log4j was way on the end of best value ever, because you could run arbitrary code. And, as we'll show, it's invisible. Under the right circumstances, you won't even know that this has happened to you. Okay? So another thing to think about is how this starts, right? And the other thing you have to understand about attacks is it's not human beings, it's bots, it's botnets, millions of devices. And the way to think about it is imagine that there's a burglar, right? You're trying to break in, and he is literally going around every door and every window, every lock he can unlock in the building, the house, wherever you live, whatever building you can think of, wherever you in the world you are, all the time, 24/7. We have bots out there, and all they're trying to do is find a little way into your system. It's fully automated. Millions of systems doing that, probing your systems all the time. Now, once they get the first connection, once they get in and go, oh, actually, I know what you are, because they're looking for some hint as the type of system you are, and they'll do that within a few seconds. So basically, you turn up, you deploy your application to Amazon or something, you open the door, within seconds, one of these bots will be asking you some information. They'll be trying to figure out what you are. And then from that, they'll grow. The more information that you give them, the more refined the data attack can be, and generally they'll try things. And the way they try things is they're like reversing your APIs, driving it in different ways. There's all these things. This is called, well, you can't see read the red words, but in red, it says fuzzing. Fuzzing is a term that means I'm going to try to use your API in ways that you weren't necessarily expecting. So if you say your API takes the numbers 1 to 10, I'll try -1 and 11 and int max and things like that. I'll try different verbs. If you've got using HTTP, I'll try the different verbs. I'll play with your API. Get that? And this is fully automated. Fuzzing is a technology that's been around for ages. It's a practice that's been around for ages. Look, long list that you can find on the internet. Go to the OWASP guys and they'll tell you all about it, how it works, what tools are out there that are pre-set up. So there's no human beings involved yet. This is all automated technologies built by people primarily designed to probe our systems, to help us discover our weaknesses, but now being exploited by the bad guys to get in there and steal your systems. Fully automated. Right? This says, with sophisticated tools. Shouldn't do red on black in a bright room. What I'm showing here are some of the extras that get added to this package. So you've got people who are trying to get into your system, bots trying to get into your system, using these tools, using these fuzzing capabilities, and it's very, very sophisticated. Right? The artillery fuzzer is a tool, a well-known tool for driving these fuzzing attacks. Zero wet space. That's an example of sending in data that you didn't even know existed. It's using Unicode, etc., in ways that your application may not even realize is valid. Big list of naughty words. Not what you think it is, right? The big list of naughty words is the list of common things, terms, descriptions that you as a developer will use. So it may be application names, API names, all sorts of stuff. Like it can be the names of common passwords. There's all sorts of stuff. The point is, it's out there, fully available for people. So these bots have all the tools, all the capabilities, all the data they need to probe your system. Right? And it's not just your APIs, it's all your data. There are vulnerabilities in image parsing, there are vulnerabilities in security protocols. All these things get probed, right? Binary payloads, text payloads, you name it. If there's a vulnerability in there, if there's a weakness, if there's a way of driving that code, driving parsers in ways that weren't expected, they'll find it. It's a very sophisticated setup, right? Everything they need to drive these attacks on you are in automated ways, well crafted. Everybody's doing this. And so that means that Log4Shell is a pretty good gift, because they have all these fantastic tools for getting into your system, and Log4Shell is basically you leaving the door open, and they just got to find that door. Now, the way it works plays on some weaknesses that we as human beings have, as developers have, and I'll go through some of those things. So the first thing is, how does it work? Well, you've all got loggers. We all use loggers in some way. As a developer, especially if you're deploying to a cloud service or something, you need diagnostic information. So things go wrong, you want to be able to collect diagnostic information. So you use loggers. We all use those. These sorts of patterns, you know. And one of the things that we do is log data coming into our system. So in your log, you've got whatever the data is. Yeah. Whatever comes in, you log. So you make some requests. You go, I need to log headers. I need to log user IDs. I need to log key. I mean, whatever it is you're logging. You're logging it because you're trying to trace through the application path so that in the event of a failure, you take the log and you go back and you go, why did my code go this way? What does that mean? That means you log the data that you get given. Whatever data comes in, you log. Because if you were to change this data, you would not be able to debug it because you're now logging data that you didn't get. And about the only time that you might even think about not logging the data you've got is if you get passwords, because we're aware of don't log passwords, right? So one, we're already decided that logging is about logging whatever we get, whatever data we come in, and that's cool. But the other side of logging is you want to know sometimes information that might be a bit more generic, a bit more flexible. Not just what the application's given you, but your environment. So if you've written an application you want to know what version of Java it's running on, or whether it's running on Windows or Linux or whatever, that might be important to you. So you log it. And so you could do system.getProperties java.version. You could do that, and that would work. But because we're developers, what happens is people go, well, why are you doing that? I can do that for you. I can do that in a more robust way. You don't have to do that. I can do this thing, logger.info version $open bracket sys : java.version. That says to log4j, when you get this string, do that. Go find out the data and put it in. So your log has whatever version you're running on, and whatever system property you need, whatever information you need. So we've got a situation where we're logging whatever data we get given, and now we have a process, what's called substitution parameters, that says if you give me certain strings, I'll expand them based on whatever I've got inside my system. Okay? So it's okay if you go, I've got system properties. Well, it's not okay, but it's understandable. And then you've got environmental variables. So you've got env on the front. You can even ask log4j about its configuration. And in fact, those substitution processes, as you can see, there's a long list of substitution processes that are available. And of course, it's Java, so you can write your own. So now the data that comes in can trigger substitution processes. Okay. So now we have this lovely position of accepting data in as is, giving it to the logger to report, and the logger reporting whatsoever is required. Okay, that's what you get. right? But as you can see over this side, maybe you get a cookie in and you log the cookie and you get the data. But if the cookie is set to, hey, one of these special values, what gets logged? Not the cookie, but it gets expanded. So there is the core. Two parts. Our need to log the data that we get, and all these fantastic capabilities that Log4j gives you to log whatever you ask it to do, and in nice, easy ways. Okay. So that would be bad enough. And then in 2014, it got so much worse, because in 2014, they put a request in, some people put a request in to add an extra lookup that was JNDI. The reason they asked for it is perfectly legitimate. What they wanted to do, just like they had with system properties, they wanted to be able to say, can you log some config data for me? Here is the here's the path to the data that I want. System property name, or in this case, some JNDI paths. Because people have configs that run with, that gets, there's like JDBC databases, the config access is all, some people store them in JNDI. That's what it was for. So you had this capability added, and it's like, cool, we've added that, no problem at all, okay? Right. And the problem was that we added JNDI to give some capabilities, but it dragged in others, because nobody understood that JNDI itself had a process and an expansion and a plugin process. So that meant you could now start making requests to get config data from LDAP or MI or DNS calls. So I have this process now where I can part in this system parameter, this substitution process, and have access to almost enormous sets of data based on whatever the system's got. Access to LDAP servers, DNS servers, you name it. And that's pretty bad, isn't it? Right? But it gets even worse, because it turns out that this process expansion is recursive. So if the data that contains $1 or whatever gets expanded, if the result is also a valid substitution parameter, it'll get expanded again. You don't get 2 log entries, you get 1 log entry based on whatever the final answer is. Okay? So in this example, I've got an environmental variable called mode, which has a value of sysjava version. And then if I try to log and ask Log4j to give me the value of the environmental variable called mode, it all substitutes itself and end up with 181 in this case. Okay? So there we go. So we have these amazingly powerful lookup processes for getting all sorts of data out of systems. We have a recursive substitution process, which I'll demonstrate in a minute as to why that turns out to be really bad. And this need, because it's a developer tool, to write the data as is. We do no validation of the data that we get in. Okay. So any data comes in that we log, whatever it says, Log4j will do. And as you can imagine, people started playing around with putting in data using these substitution parameters everywhere to try and figure out how to get into your system. Now, this is not about your application being internet facing. It's got nothing to do with that. It's to do with the data you log. It just so happens that quite often, well, we log cookies or access IDs and all sorts of stuff. But it's equally valid if the data that you're logging is a record in a database. Could be any of those things. Right. So who'd like to see a demo? Who'd like to see this in action? Yes? Yes, this is the fun bit. Right. I've got to find it now. That one. Yeah, okay. Right, so now I've got to figure out what I'm doing. Okay. Come on then. Is that coming up? it's a bit fuzzy. Okay, so 9th of December, everything goes bang, and for next month, I'm trying to figure out what it's all about. And part of that, I create some demos and apps because I want to explore this. So this app, there's a little app in there which you can't see, which says to-dos, and you'll see some answers in a minute. Let's see if I can make it work so that you can see. Right, so now I've got to find my mouse. Okay, I can't see it. Anybody see my mouse? That's no good. I cannot see it. Oh, there it is. Okay. All right. Okay, this is going to be fun. Okay, how are we going to do this? Okay, this is going to be a short demo because I can't see anything. I'll tell you what I can do. I'm going to do it on my side and then I'll shove it over so you can see. That might just work. Can we turn the lights off? Is that possible? I cannot see what I'm doing. Thank you. Does that make a difference? Not really. Okay, so. Right, there's that. Where's my mouse? Can you see my mouse? Oh, yeah. Okay, right. Oh, this is just going to be torture, isn't it? Okay, right. So, okay. So I'm going to type in, just so that you can see this. So I have this application that's called it's a to-do application, right? Oh, thank you. Right. So let's see what happens. I've got to keep my hand on the mouse. Okay. So it says, you can see in the middle of the left, sys.java.version. Okay. Right. So I'm just going to it's a to-do list. So I'd rather like buy milk, which I would demo, but we don't have the time. I would do this instead. I'm going to put in some data. Okay, now you can see the top right that says application consoles. So I've got various versions of Java I could select, and I've also got down here, if we go up, now I've lost the mouse. I've got a bunch. Oh, I've gone all quiet. That's better. So you can imagine I could play around with this stuff, right? Which we just do not have the time for, but it can be informative. So let me go back so I can see what the hell I'm doing. Okay. Right. So I'm going to pick a version of Java. Let's pick that one. Okay, and then let's see if we can see this working. Okay, right, so there we go. So it says system blah, 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 and then I've got to find the enter button, and I go enter. Oh, that's wrong. Can't see it. Oh, I really can't see it. Oh. I may just do a text demo. I really want you to see this. Okay, bear with me. Okay. I wonder if I can do this half. Can I do this halfway? If I do that. Ah, that'll work. Oh, no, it won't. Okay, now I can't see that either. Okay. I'm going to skip this because I can see where this is going to go. But luckily, I have it in the slides to take you through it. And I'll see if I can help make it a bit more obvious if we do that way. Okay. Okay, let's go back there. Okay, so what you didn't see was a bunch of those exploits. Okay, but I have got them written down. Okay. So this sys.java.version thing you saw is easy. And you can imagine that comes in, and what happens is your log, so that comes in from the bad guys, they insert it however they manage to do it, so you log it, and you get that. And the Java version's interesting because that tells them what version of Java running. And then they'll ask you about what class path you've got, because then they can figure out what code you've got running on your system. And the thing to understand is all they've got to do is get that data out somewhere. So currently, this particular example is going to get data logged to your log. So the class path ends up in the log. Who cares? It's your log. Right? Well, the problem is that everything can be compromised, and even your logs. So all it takes is the wrong configuration, and then your log is on Google because it's accessed. And in which case, they can read your logs. It's a mistake, right? You didn't intend to do it, but it happened. They exploited it. And like I showed you with the tools, there's a whole wonderful way of driving Google to find the stuff you want. It's not hard. Do you know Google could do these things? If you're really interested, there are these things called dorks, Google Dork descriptions. I have no idea why it's called dork, but literally it is a database of queries that you can put into Google to find compromised data. There are dorks of finding passwords, there are dorks of finding files, you name it. There's all sorts of ones. So here we are, index of it. Files containing juicy info, there's loads of them. Go have a look. Right? The point is that even the little vulnerabilities of being able to get your system to report data that you don't want to give out can be useful. And the other thing about the log4j was, we said about JNDI being added. JNDI dragged in LDAP. And LDAP, what happens is that the JNDI substitution process talks to LDAP and says, do this. Gives it this URL. And this is just a made-up one, obviously. But what happens is it makes a call with LDAP. It does an LDAP call to a URL, and it logs whatever data it gets back. That's what it does. You can imagine that this information being parsed here, right, this is hard-coded. It doesn't have to be hard-coded. It could be a substitution parameter itself. So I could easily make a call. I could easily put this parameter in so that you log it, and as part of the logging call, I can say also another substitution parameter that says, tell me what the version is. And then a call gets made out to my LDAP server, and you give me my data. Okay? And I can then leak all the information I need. And at the very least, I now know that you've got a compromised server because you just told me. Because now I know that you exist. Because I made you talk to me. Okay. So there we go. I think I've just said this, but look, you can see I can make a call and I can pass in. So that first white line is the first line comes in, cn equals version. Yes, so this one comes in from the bad guys, however they get into your logging system. Okay, and so you trigger it. Your LDAP, your logging system says, okay, I've got to do that. I'll make a call to LDAP. So I make a call out to the bad guy server. The bad guy server sends me back a string. And that string looks like the second line. And that string includes, tell me what version you've got. And so the logging system sends that data back. Okay? And that can come back with all sorts of information. I've now got a communication mechanism because of this recursive process with the substitution parameters, where if I get one, I keep expanding it. And log4j is doing that under the covers. That's the call that comes in. Whatever happens between then and now, the only thing that gets logged is the very last piece of data. This conversation is unrecorded. The only way that you would know is if you happen to be looking at the calls out to remote servers. And believe me, it's not going to be as simple as making 50 calls to the same server. Botnet, remember? It'll be different IP addresses, different URLs, hidden, so you won't spot it. That's what's going on. Now, this is bad enough, but there's a thing called a gadget chain. So these LDAP servers return strings, but they can also return Java objects. So I can actually make a call out to a server and get back code that can be executed. You said right at the beginning about the bad guys trying to execute code on your system. The LDAP mechanism is designed to return Java objects. And that Java object will get expanded, and whatever the two-string result is what gets logged. But as part of the expansion, because it's serialized form, code can get executed. Bad things can happen. The very simplest version, it's just going to try and make use of whatever you've got on the class path, which you've already told it because it asked you previously to tell me what your class path was. So I have all the data I need to send you back a really simple gadget chain so I can exploit it, right? And gadget chains can be complicated. They can be maps, they can be hash tables, you name it. There's all sorts of ways they could get data back to you. And it's all about serialization. I'm now into all that realm of badness that I can have with Java serialization. Right. Okay. Let's move on from that because I'm going to give you the chance to answer questions. Gadget chains can break your system because the serialized form of data that I get back can be of the form where it can ask for objects of massive size because it's serialization. So all that happens is the serialized data comes up and the JVM goes, oh, it looks, I need to create an array of 1 billion objects. Okay, done that. Use a load of memory. First object, oh, okay, it's an array of 1 billion objects. I've done that. A bit later on, out of memory. So imagine how you feel if all I have to do is make a call to your server with a particular substitution process parameter, and that causes your system to crash because of this. That's happening. Right? Let's move on from that. And then the best one of all is arbitrary remote code execution, because the object that comes back, and this is a JNDI LDAP thing, the object that comes back in the right circumstances, so it's the right version of Java, okay, can be what's called a reference object, standard Java thing. And a reference object says, by the way, any code I want, any code that I depend on, comes from this URL. So I get back an object that says, here's the first object to instantiate, and any code this depends on, download it from this place. That means completely arbitrary execution. I can run whatever code I want if you have the wrong version of log4j and the wrong version of Java. Okay? Yeah. So these RCEs, you just need an object that has this object factory, and it doesn't even have to exist on your system. That's the horrible thing. It exists on the bad guy's system. It comes in, and JVM goes, oh, it's one of those. I know what to do. I have now in this mode of loading remote code. And this all happens under the covers because of that substitution process happening inside log4j and not being visible. So I can have very complicated calls, pass data backwards and forwards, run whatever I want, install malware, steal your data, change your data, that easily. You just have to be in the right space, the right configuration for that to happen. Okay, I think I've done that, yeah. Yeah. Now, it turns out that some people thought they were not vulnerable because they did some tests. And it turns out that Log4j has this checkered history from 2.0 onwards. And depending on which version of Log4j you've got, you may or may not be subject to some of these attacks. Not sometimes because the feature wasn't added yet, if you have an early version of Log4j, but if you have a later version, there were some bugs that meant some of this code failed. So you're lucky. But then it got fixed. So then you upgraded to the next version and suddenly, you're vulnerable. The takeaway from that is just another example that whenever you're looking at these situations, you can't rely on your safety being just because it doesn't fail now. Because you can upgrade one of your dependencies could upgrade one, right? Any of that could happen, and suddenly you're vulnerable again. So always in these complicated situations, or where you have very dangerous CVEs like Log4j, you have to go to the latest version. You absolutely have to go to the latest version. It's the safest thing you can do. Even if you think you're not vulnerable, you probably will be. Right, so I want to move on a little bit. I think I mentioned you can't see the red, yeah. So what I was going to show you, because this is how I was going to end the demo, was this, going back again, just to reinforce, data comes into the system somewhere, it's at the right format, you log it, Log4j parses it, and it kicks off this process because it makes a call out to remote server. And then a conversation takes place, and then eventually there'll be some final thing that comes back, and that's what gets logged. And it'll be innocuous. It won't be, thank you for your data, but it will be something simple. And then it's gone. You have absolutely no idea that that's taken place. So Log4j is not only dangerous, vicious, it's easy to exploit. They can run really bad code, and you will never know. And let's just go to the last bit. If that's bad enough, I said about moving to the latest versions. Well, we're not. This is a snapshot from Sonatype's. So I work for Sonatype, if that wasn't clear. We run Maven Central, and we keep track of the downloads. And you can see when it first came out, the Log4Shell vulnerability was pronounced, that everybody updated. Lots and lots of updates. Great. But not 100%. And right now, whatever number you look at, you can go look at live data now, we're in that number. 30, 40% of people are using vulnerable versions of Log4j. And when I say people, I mean code. Somebody's downloading these, and it's part of some other thing. And it could easily be a dependency that you're using. Because as we've realized, the tools that you use to find out whether you're vulnerable are not all equal. There are many tools out there. Some of them will figure out that you've got a Log4j problem. Others won't. So if there's one other takeaway from all of this, is that you need to go back and look at the tools that you've got and ask yourself, is this actually able to find my Log4j dependencies? You can't rely on it anymore. You have to go test it. It's not particularly hard to write some test case to see whether your tools do what they're supposed to do, but people tend to take the tools that they're on face value. So, or they may go, I'm using Dependabot, and Dependabot won't help, because Dependabot only finds the top level dependencies, the dependencies of your application. It won't find the Log4j that's 3 dependencies deep. That's what it's not for, it's not designed for. Right? So you need to go back and have a really good look at how you manage dependencies and what tools you use to find them, and make sure they actually can find these vulnerabilities, because currently 40% of us sitting in this room who think they're safe aren't safe. Right, I think, given I have 2 minutes 55 on that clock, I will stop there. Any questions? Anybody going, I need to go home and patch my server? There's a question at the back.
Yeah. So we have this big vulnerability since 2014.
Yep.
With these big and other researchers trying to find, and in Insight it's a easy one to exploit. So how do we have 7 years and nobody raises a flag?
Well, yeah, okay. So it was raised, but it wasn't raised. It was raised. A lot of the black hat communities spotted the vulnerability potential and reported it, as in told the Java community this is a problem. It never got fixed. And do you know why it didn't get fixed? Primarily because it wasn't seen as a bug. It was seen as a feature, and this has been added for people for your use, right? Right. Now, and I don't know whether I interrupted you, but the other thing to think about is just think about what you said. This thing has been there since 2014. It's readily exploitable. So what's the correlation? It means it's been exploited, right? And there is evidence turning up now that says, yep, this has been used. And we've got amazing evidence of Log4Shell being used to add malware to firmware that ends up in your routers, you name it. It's a wonderful way in, and it's been exploited. The only real difference between 2014 and now is the scale of attacks have grown. In 2014, we still had, I wouldn't say under control, but it was still mostly a commercial activity. Hacking was for money. But what's happened very recently, and you would have seen this in some of the situations happening in like the Ukraine, where the realization is that this isn't just good for hacking for money, it's also a wonderful way of inserting malware into some other person's supply chain, and to find ways to compromise or be prepared to compromise the supply chains of your country. And so now what we're seeing, this is why this is even more important than ever, that this isn't just a vehicle for getting people to bring ransomware into your system, which is bad enough, but also targeting you because you're part of a supply chain. We're all part of a supply chain, right? And they're trying to get into your supply chain to hide controlling software so that at the time that they need to, they can disrupt your systems, bring trains to a halt, stop food being delivered to supermarkets. That's the objective. Not necessarily to be triggered now, but to be triggered when necessary. Yeah, scary, isn't it? Okay. Do I have time for some more? Yeah. Any more? No?
Thank you. Just a small question. As I understand, the main vulnerability was in the GNDI module. I mean, if someone has an old version of Log4j, is it good enough mitigation just to ban the affected module, the GNDI module? I mean, I think it's a library.
Well, in theory, yes, because people have been saying one of the ways you can hack this was to go into all the jar files of your system, find the root JNDI class and kill it. And you can do that, but what happens the next time you do a build and you pull down the updated version of it. So you can do that. You can hack it, and some people did, because it was seen as being the best temporary compromise. But it's not a long-term solution. And just to rub it all in, that particular class being spotted as being a wonderful tool, people started taking it out and using it in other packages. So apparently, I haven't gone looking too much, there are other open source projects out there that also have that sort of capability, the LDAP capability, built in because it was useful. And we're also seeing it being used also by the bad guys because, again, it's another little way of getting data onto your system. Because one of the things about malware delivery is it's a very staged process. They get the smallest piece in first and then grow. So the JNDI class has been used in a few places for that sort of stuff. Yeah. Now, if you thought you were leaving Jnation and you were going to be happy, I hope that I've made sure that you're not. Right? What can I say? It's a bad place. We are in this bad place. It is happening now. And a few years ago, it was bad but not horrific. But now, because of the fact that the bad actors are doing things for different reasons, and that has now become mainstream, this sort of problem isn't going to go away. We're going to get more of it. And even more scarily, this one got reported eventually. We have lots of evidence that says the ones that turn out, the new vulnerabilities that turn out to be very lucrative, very useful, won't get reported. Because actually the people who are finding this are being paid off not to report things. And not trivial amounts of money, many millions of dollars. Because you can imagine that the person who, if this had been a brand new one and somebody had found it, and then they didn't report it, but it was used by state actors, so think of how valuable that would be to them. Right? So you have to take that. And the other thing to remember is you are all part of a supply chain. Right? We all provide services, whether it's software services or something else to somebody else. We consume them. We know people. We're all potential targets in this new modern attack surface because of who we know and what we do. So it's not about banks, it's not about finances, it's about the fact that, I don't know, you produce leather goods and you sell those leather goods to the military that keeps the trousers up. You know, there's all these connections that they're looking for because each one of those could be disrupted and it affects both your economy and your ability to act as a nation. And that's the new reality. That's where we're going. Right. So there you are. Thank you so much for listening. There's another talk, isn't there? Oh, we're doing another Jeopardy. For those of you who missed it, we're going to try and squeak in another one in a few minutes. If you're interested in coming along and throwing rocks, if you're a speaker here, you should come and participate. No excuses. Yeah. Other than that, thank you very much.
right. Time to get started. So it's last session of the day. It's basically me between you and the party. So it's gonna be tough. It's, at least I guess for many of you, it's one of the first events after the pandemics, after the everything. So it's kind of very tempting to start with like, can you see my screen? Is my camera on? Is my microphone on? You know, all the things that we've been hearing for 2 years. But we're not going to do that. But we're going to do something else. So speaking of, you know, technical checks, up with your right arm or left or whatever, it doesn't matter, both. Yeah, go ahead, do it. Good. So now we know that those are working. I will ask you to use them because I have a talk, I have slides, I have material, but I really want it kind of to be, it's the last session of the day, right? Let's make it a bit more interactive. There is no point of me just standing here and broadcasting for 50 minutes. We can do things. So use your hands. Now, you know, now I know they're working. Use them. We'll send the mic around. You can ask, comment, you know, anything goes. Questions, feelings, comments, you know, anything. Crying about serverless applications, that works too. Or cloud-native applications. All right, so what is a modern cloud-native applications? There was a session a bit earlier by Holly that she talked quite a bit about a lot of aspects of that. And this is going to be a little bit different kind of look at the same thing, cloud-native applications. So this is a little bit of a retrospective, in a way, of the applications that we're being asked to develop. I work for a Norwegian consultancy company. We develop different applications. We consult different kind of customers. They ask us to do different things. So this is a little bit of kind of, you know, putting all together and what makes a good application, what makes it cloud native, what makes it a good modern application, but also a little bit of, like I said, retrospective on all those kind of things. So when it comes to applications, what do they actually ask us very often to do most of the times? Typically, it would be two kinds of applications. So it would be an application as we know it. It could be like web app, mobile app, or, you know, desktop app, whatever. Or it can be some kind of data pipeline because we need to process data and everything. So what things that will be different between those two would be that applications will be more concerned about performance, UX, you know, make it useful, make it nice, make it pretty, you know, all those kind of things. And usability is an important thing, and so on, right? With data pipelines, it's a bit different. You don't really care about how it looks. There is nothing to look at. It basically chews data and spits something out. So here you're more interested in how much time it uses to chew through that data, and how much data it can actually, you know, take in chunks at a time. But so kind of different, right? Different, but still a little bit the same. So what is the same with those things usually is that they need to be scalable nowadays. I mean, we used to do things different. We used to do it back in the days when I started working, when I started developing writing professionally software, things were quite different. Now we are more into microservices and all that, but we'll get back to those kind of things. But the point is now, we want those applications, no matter if it is an application or a data pipeline, we want to have them scalable, so they can scale up, they can scale down, they can, you know, respond to the way things change. This is 5 things that is a little bit of the why. I will explain why I called it the why, but you'll see it in a second. But for now, just keep it in the back of your head. So usually the things are there for a reason. We want to have applications quick and usable and everything for a reason. So you can call that a business needs, right? You have an application and you want to be able to release that application as fast as possible to the market because, well, we've seen a lot of cases where 2 competing companies would kind of race to release a service. One of them just manages to release it by a few days earlier, by a week earlier, whatever, you know, and wins the race, and everybody uses that, and nobody knows what the other one actually was called a month later or something. So ability to release things fast is an important thing. That's what businesses come and ask us. They were like, we want to develop this thing, and we want that be able to be fast and have this short time to market thing. Another thing is agility. And by agility, I don't talk about like agile software development and all that. I mean, that's fine, but this is not the thing I'm talking about. I'm talking more about the ability to respond to change. So it's kind of related to time to market thing. It's basically like when something new comes up, new functionality, something you want to release, you want to be able to do that as fast as possible without taking down everything else. So like again, in the old days, when I started working around like early 2000s, we would have a service running on Tomcat and, you know, new version, you take everything down, you patch it around, you deploy a new version, everybody's happy, you had a downtime of half an hour. It's kind of not really acceptable nowadays, is it? So you need to be able to respond to change, you need to be able to respond to change in a graceful way, and there is a lot of aspects of that. So one of them is downtime, but also how do you add new functionality, how do you add some other things to it. Another thing is, and it's kind of starting with kind of obvious ones, and it gets into a bit less obvious ones in a way. Reliability is also relatively obvious thing that customers ask for, right? Obviously, you want to have your app that is reliable. You want your app to be there for your users no matter what, rain or shine kind of thing. For that, you need a few things, right? You need to try to automate your things to make things, automate deployment, automate scaling, automate health checks, you know, all those kind of things. So automation in many different ways, automate tests. You want to make it scalable because, you know, if you have one user, you want it to be able to respond. If you have 100 million users, you still want that thing to be able to respond. Maybe you will not have that amount of users, but that's a thing you need to think about depending on your use case. If you're a tiny little startup, that's probably not going to have that. That's totally fine. Don't think about that. But if you're expecting some kind of surge of users or something, or believe or wish or whatever, maybe you need to think about scalability. And then you have the availability, right? You know, is it going to be available? Is it going to be available nearby? Is it going to be available for that specific region in the world? I mean, it can be. Is it going to be a global thing? Is it going to be just for Europe, just for Americas? I don't know. Thing that you need to think about. The availability is a thing. And also, the next thing is resilience. And by resilience, I mean, that's what, again, what typically customers ask in one way or another, in different wording, but it always boils down to, you know, well, it needs to be fault tolerant. It needs to be able to behave when something goes bad. And that's not always they actually ask that. They just kind of assume that, or they get really, really pissed if it's not there when you develop things. So this is kind of getting a little bit more obscure. It's kind of obvious when you see it on the list, but it's still a thing that you need to think about, and you kind of need to expect them to be there. And by resilience, I mean a few things. So typically, fault tolerance is one thing. So if something goes bad, what do you do? Do you do exponential backoffs? Do you have failovers? Do you have some kind of strategy? Do you just, you know, let your application crawl into a deep dark hole somewhere in the server and just lie there in like, you know, just waiting for it to be restarted? Or you actually send a nice message saying, hey, sorry, you know, something went wrong where we're working on it, just come back later. Observability is another thing, and it's getting a bit more into things that we didn't use that much before, but it's getting normal, it's getting more useful. So observability is about kind of making sure that your application is actually doing fine before things go bad. So you can actually, set up metrics, you can set up things, you can actually have a quick look at how your application is doing and how, basically check the temperature of the whole thing. Is it going to blow up soon, or we're good? And then you can do a lot of things with it. You can set up, alarms and things and blah, blah, blah. But this is now we're talking about the business needs. Now we're talking about problems, in quotes, without solving them just yet. Security is an obvious thing. Security comes in many shapes and sizes, but, security, to make them secure, this regular, confidentiality, integrity, and availability kind of aspects of security. And the winner of the list is probably the lock-ins, and people go quite crazy about that. They talk a lot about lock-ins, and sometimes we work a lot with customers migrating to clouds, migrating to serverless applications, things like that. And then you would say, well, you are moving to cloud X or cloud provider X. Why don't you use this managed service for the database from that cloud provider? No, we can't do that. Okay, what do you want to do? Well, we're going to set up a VM. We're going to put Postgres on top of it, and we're going to run that. But you're moving to cloud. You want to scale. That thing is not going to scale. No, but we don't want to do that because that is going to introduce lock-in if we're going to use the managed service. Exactly the same Postgres database managed just by somebody else. No, we can't do that because it's going to be lock-in. And that's kind of really, 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 really bad misunderstanding of the whole lock-in concept. And if it sounds weird, believe me, that has happened. I've had that conversation. And it kind of, yeah. So lock-in is a very kind of misunderstood thing. Again, relatively obvious when you just sit there. It's like, obviously we don't want to have a lock-in. But how do you define lock-in? Is like choosing if you're going to develop your application on Java or .NET. Is that lock-in? Or it's lock-in when you choose a cloud provider? Or is it lock-in when you use a specific framework for something, I don't know, for logging or for front-end or for whatever? So where is your actually definition of lock-in and where the boundaries go? So that's a kind of important thing to think. And usually the business needs part of this is kind of unclear, so you need to dig deeper into that. So this is what they usually ask us, right? And the what part, again, we've had the why, now we're going into the what, and soon we'll see why they're called that. Scalable applications. So scalable applications, what do we mean by that? You can have them, they come in different shapes and sizes, but typically that would be something like something that can run on the cloud. And I mean can. Not must, not have to, but can. It can run on a public or private cloud. It can be on a multi-cloud. And it can be a hybrid cloud. So, well, public or private cloud is kind of obvious, right? It's a cloud service, it's there, it's running, we're good. Multi-cloud is a thing that where they might ask you again, the customers, and there might be needs for that, where you use separate cloud providers for different things, or maybe even for the same things. As a kind of, because you have supercritical application, you really need to for that thing to be available, and you don't really take a chance that anywhere, anytime, anything can go wrong. So you actually do like super failover thing running on two different clouds. You fail over if anything happens somewhere, you just go to somewhere else and all good and everything. And this is a very extreme case. Most of the cases it would be some other reasons for that. It could be, for example, that you your data want to be processed somewhere, or your applications want to be processed somewhere, or even more obvious reason for that would be pricing. Something is cheaper on one side and something is cheaper on the other side, so you kind of pick and choose. Last one is hybrid cloud, and that is combining your own servers, your own racks somewhere in your basement with some kind of cloud provider. And that is, again, a few reasons for that. A typical reason that we often see is some kind of thing that we're not allowed to send data somewhere. We're not allowed to ship data, or our customer does not want to do that. Or it can be something like we have super special hardware. We have like super weird special application that does something on GPUs, and those GPUs are impossible to get hold of in the cloud, so we need to buy them all, set them up, and use it on-prem, and the other things will be in the cloud. So that can also work like that. So scalable applications, they can scale, and again, can run on different clouds, but they don't have to. So now that we've had those two parts, so we have requirements from the customer and why usually they ask for things and what they usually ask. Now I want to kind of take a step back and look into this cloud native thing that I kind of mentioned in the beginning and then partially forgot and didn't say much about that. So I give you a wall of text, and late in the afternoon, this is a very, very bad thing to do, and I'm fully aware of that, and I probably lost you already to the wall of text. You're way into that text and reading that and parsing that thing, and you don't really even hear a word of what I'm saying. So to kind of let you, to snap you out of this thing, I highlighted a few words. To snap you out from that thing even more, I removed some words. So now we're kind of having interesting. Now it's getting a bit interesting. And if I click one more time, you kind of understand the what and the how and why. We did not talk about, we talked about what, we talked about why. We did not talk about how. So this is kind of, as you can guess, that will be coming soon. But, you know, look, we are actually, CNCF, Cloud Native definition. So CNCF stands for Cloud Native Computing Foundation. And they say, well, we want to build scalable applications that can run on public, private, and hybrid or hybrid clouds. We want them to be loosely coupled, resilient, manageable, observable, with robust automation that changes frequently, predictably, with minimal toil. And how do we do that? Well, you know, containers and service meshes and microservices and all this fun stuff. Declarative APIs and infrastructure and all that. So I promised you 5 tips, and 5 tips really come in the part of how, because, you know, usually the why is kind of given. The what is kind of given, but it's up to you to implement things. And this is the how part. This is this is kind of the 5 tips, really. The important thing to say, I'll go back so I don't lose you to that wall of text again. The important thing to say, because I showed you 5 things, I blinked on the screen, it will come back. But those 5 things can be implemented in any order. It does not have to be implemented, all of that, and they do not have to be implemented 100%. So, again, you have all those 5 things. You can do a little bit of number 1, you can do a little bit more of number 4, and do nothing about number 5, and you're still good. The point is, it will make your applications a little bit better. It will move them a little bit towards the right way. And the other thing is that it's important to say, and I'll probably repeat that again and again and again, is that this is not a recipe for like super cool applications, and you don't have to do that all, and some of those things or all of those things. You really, really, really need to ask yourself, why am I doing that? Why do I want things being containers? Is it just because, everybody else is doing and I really want that to happen? Or is it because I really need that? Is it because I have actual need to have loosely coupled microservice applications with service mesh and everything? Or is it because, everybody else is doing that? Because you're not everybody else. Your needs will be different. Your requirements will be different. And it's actually your job when you're asked by your customers, whoever is asking you to implement things as a developer, you kind of have to ask that question, pass it on, and ask like, yeah, okay, cool. We can do microservices, but why do you really want me to do that? I mean, what's the point of that? Because sometimes people just do it just because, and that's probably a very, very bad idea, because you'll end up creating more troubles, creating modern cloud native applications for no reason, spending a lot of time, and then spending a lot of time managing them, because it's not coming for free. So let's say loose coupling. Loose coupling is a very nice thing. We've been told for years and years, and it's like, ooh, you can create loose coupling, then you can take down something and you can take up something else, and it's going to be magnificent. Maybe. But with loose coupling, you have to think about architecture. You cannot just throw things around. You need to think about things like APIs. And once you do APIs, how do you manage your APIs? And then you introduce microservices, and then those microservices need to talk to each other, so you have more APIs, more management of APIs. How do you version them? How do you do all that? With all those microservices, they need to talk to each other. So service mesh, ooh, yay. How do you manage that? How do you debug when something goes wrong? How do you make sure that your microservice A fails in a graceful way and microservice B does not go totally haywire because that one is down? And all those things, I mean, there is a cost for that. And there is a really kind of big cost for that, because, well, okay, it's going to be pretty. You can take it down and redeploy and everything. But again, do you really need that? Do you understand me correctly? I mean, I love loose coupling. I love it, but like for its own use. It does not mean that you have to have that. Containers is kind of more or less a little bit less no-brainer. You put them in the containers and everything, but then again, do you really have to put them? Do you have actual microservices or something worthy putting in a container, or you're trying to shove a huge old monolith into a container, so it's basically finding a tiny little lunchbox and trying to shove an elephant into it, and then closing it. It's like, hey, I have a container. But well, elephant is not really enjoying that container, and that container is not really enjoying hosting an elephant, and nobody's really happy about that. Again, I've got the mental image of an elephant in a tiny little container, and that was kind of weird. But containers is an important thing, and it's not just for things that you typically think about. It's actually it's a lot about predictability and predictable builds, so you don't have this works on my machine thing anymore, and predictable deployments, because if it works on my machine on a container, if you have a similar architecture, a hardware architecture, it's most likely it's going to be really strange if it doesn't work on your computer, on your machine or your servers and stuff, right? So it's about predictability of your both builds and deployments, because back in the days when I was writing my first lines of code at like my first year at work and stuff like that, we would write applications, we would write along, and I kid you not, I mean, those documents were like several, like 20, 30, 40 pages long with deployment descriptions, like, 1, do this, 2, download this package from this file server, 3, unzip it, 4, put it there, 5, do like 5 prayers to make sure that it actually deploys, and all, it goes really, really long and really detailed. Now you don't have to do that. You just send a container or even Docker file possibly, and then you have a container registry somewhere and things are getting deployed, and it's really, really nice. So predictable. But it's also portable. because you can actually, you remember that lock-in thing? You can actually, if things are in containers, most likely that you will be able to port it from one service that can do containers to something else, maybe with some changes. Maybe you'll need to do some changes, but those will be relatively minimal compared to what we used to do with just installing things right onto the hardware, onto operating systems and stuff, and having, again, those 40 pages long descriptions. That will take some time. That will take some trial and failure, and it won't be possible to, or it will be very hard to automate. Speaking of automation, automate all the things. And it's not just like a funny kind of thing, like, all the things, something, all the things. Really try to automate all the things. Because we humans are kind of, we're very nice creatures, but we tend to make mistakes. And we do that quite often. And we do that especially very often when things get boring. I mean, going through 40 pages document, installation guide, you fall asleep halfway, you go and grab coffee, you forgot which point you were on, and then you just move on, and then you make something wrong, and then you mistype something, and then you spend 300 hours trying to figure out that it was just a tiny little mistake in a config file. With scripts and automation, that doesn't happen. It just goes quickly. It goes like every time it will be in the same way, and all those kind of things. So you save time. You get to do fun things. You can actually, I don't know, while it's being installed, you don't really even, if you don't have to work, and you can just jump on a bouncy castle and have fun, and then come back and it's like, oh, it's working. It's actually deployed, right? It's less error prone. We talked about that, and it's less toil. You remember that toil thing in the description? Well, automate as much as possible. The next thing is, now it's getting, again, a bit more and more obscure, maybe. I mean, those first three things, it's more or less standard now. We kind of know that it's a good thing. We probably do that for one reason or another, and all that. Resilience, sometimes it's a bit hard to make people do that and understand why do they need to spend money and time and resources of their developers to develop that instead of creating new fancy shiny features. And that actually goes to a lot of things, especially automation, testing, things like that. It's like, okay, so I have you as a developer for a limited amount of time, obviously. Like, say you're working for me for a year. I can use you for a year to develop new fancy features every time, every day. Or I can use you half of the day or half of the time to developing something that my customers will never see, and then use the other half to develop shiny features, so I get half of the shiny features. So why would I do that? This is kind of the typical thing that usually happens. So you need to really work hard to explain why that half of invisible work for external users is actually an important thing. It goes for automation, it goes for resilience. So with the resilience, how does, I mentioned that a bit earlier, right? How does your application behave when one of the microservices is down? How do you behave when something that's out of your control, some other service somewhere out there is not working properly, is returning something, or it's down at all, or is just giving you some weird HTTP errors or whatever? Do you make your application observable? Can you actually, do you expose some kind of metrics saying how well it's doing, or how bad it's doing, or how much memory or CPU or whatever, how many users it's using? Depending on what your application is doing, you might want to expose some kind of metrics. And if you do that, you can again automate things, right? Because I did not mention the K word here at all. Kubernetes. Because again, people do that for no reason, because everybody else is doing that. That's a fashion now. Everybody my Kubernetes is shinier than yours, and it's fantastic. I have 20 nodes and lots of pods, and what do you use it for? Well, it just stands there. But the thing is, if you actually have to run on Kubernetes, or if you have to do serverless that we'll be talking in a bit about, you can actually use those metrics to scale things. automatically, right? You can actually make those things observable for a machine to know, oh, well, now things are getting a bit hot, so maybe we should spin up another instance of that, or maybe we should spin down something, or things like that, right? Well, security is kind of obvious again. Not going to talk much about that, but then you need to protect your endpoints, you need to protect your data, you need to do all that. But I mean, that's a different kind of story. And then there is this thing of serverless, and serverless is a kind of, again, misunderstood, slightly misunderstood child of the whole thing. A lot of people think, first thing they think that, oh, if I want to go serverless, I need to be on a cloud. Or if I need to go serverless, I need to have all these crazy things like loose coupling, microservices, blah, 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 blah. And it has to be like super fantastic. We need to have infrastructure as, I don't know, a Netflix or Google has for my tiny little startup to go serverless. But you don't have to. That's the thing. You can actually experiment with serverless without doing things on-prem. Because serverless is not about, obviously, it's not about lacking servers. We kind of learned that after a while, but it's about lacking of this toil of configuring things or making things work. So now you can actually run serverless. There is a Knative, there are some other things, that there are also different flavors of serverless. There were a few talks today that also discussed that. Meta had a talk where talked about like the serverless is not just functions anymore. You can actually do containers and things like that. So you can put your containers on-prem into something that will scale down and up and things without thinking that you only have to have a tiny little functions, or you really need to go to the cloud. For the cloud, the answer is why is kind of easy. You save money, pretty much, right? If you're getting billed by amount of time your application runs, the CPU it uses, memory it uses, and so on, so on, so on, well, you scale down to a very minimal amount or down to zero. Again, that's another kind of very hot topic. Should we go to zero or should we kind of minimize it? We can probably talk about that for an hour, but the point is, you will save money because you will be billed for less hardware being used. For your own on-prem thing, it kind of is true as well, but it's a little bit different way. In here, you don't have to scale for all of your maximum use of all of your applications. When you buy servers, you can actually share a little bit of hardware between applications, because typically your applications would be in different phases for different at the same time, right? So some applications might be used a lot, some others are not. Then you kind of scale down something else, scale up something else, and then you go up and down. And then you save money, you save hardware, you save. You don't have to buy, you don't have to create something that will be for the worst case scenario. And then you can also obviously combine it with cloud, so you can run everything on your own, and when the pressure gets too high, you can actually outsource some of it to the cloud, scale it up over there, and then scale it down when you don't need it anymore. Like, to give you an example why this is thing, so in Norway we have this tax return thing, and it mostly happens automatically, and then they just send you an email saying, hey, your tax return is ready, just go in, have a look. If it looks good, you don't really have to do anything. If it's not, correct it, we'll fix it, and then we'll recalculate if you have to pay or if you get some money extra back or something like that, right? So what happens is, like, Norway's population is around 5-something million. So you can imagine, well, how few millions of those are grown-up people paying taxes. So you basically, the tax office sending message to everyone is basically asking to DDoS them for a day, because everybody gets a message in one day and everybody wants to check if they're going to get some money back. It's super exciting. If you're going to get like 100 euros back, it's like, yes, I did it. In reality, it's still your money. You just paid too much. You just get them back, but it still feels good. But they needed to scale, and they had a lot of troubles with this. They were trying to figure it out, how to do that, because they would end up buying hardware enough to serve 5 million people, or well, maybe 3 million or 2 million or whatever, and that would be used for once a day, or one day a year, or maybe a week a year, right? So makes no sense. So then you can actually do scale out to cloud, you can do some other things and everything. So that is a little bit of the serverless. So these are the 5 things that you should try to see if they fit into your application. Do not do them, again, I will repeat it probably many, many, many times, but do not do them just because they were on the slide, just because I told you they're cool. You have to have a use case, you have to have a use for that, and then you can actually do that. This is pretty much it, what I have of the kind of, my thoughts on what makes a good modern applications and how we can make them better. And it would be really nice to see if you have any comments, any questions, anything. Anything goes, like from, well, this is wrong, to this is good, or, I have this problem and somebody is trying to stop me from solving that. I saw a hand over there, yes?
So you mentioned scaling and the K word. It's been haunting me recently since I've had a client who wants scaling. He just wants it. Do you have any tips on how to justify this scaling? So sometimes components, for example, a syncing component, it doesn't make sense for you to scale 10 pods when you're trying to sync one thing across. Any tips on how to avoid the architecture, especially when the architecture is being built as we go?
Well, that's a very good point. So I would say, first question I would ask is like, one thing, scaling does not equal, or, it's not always connected to Kubernetes. You can run Kubernetes without scaling, kind of, or you can scale without Kubernetes, also kind of. But they're not like fully coupled. They're a little bit loosely coupled, if we can use the same kind of way of thinking about things. But first, do you really need to scale? That I would ask. I know that you're kind of, probably I can guess what you're thinking, but so you ask the customer, like, do you really need to scale? Do you have a fluctuations of users, or you have a standard kind of pretty much same load all the time? That's one thing. Number two, when you scale things, do you really need, do you have enough load to justify using Kubernetes? Kubernetes is good and everything, but it's still at least 3 or 4 virtual machines, pretty beefy virtual machines, typical setup, right? 3 nodes, master, and or main now it's called, I think. Do you need all that machines running 24/7, producing a lot of heat and using CPU? Because it's quite intensive. Do you have enough users to do that? I did the same mistake. I put a tiny little application that we were using for like 2 months a year on a 3-node Kubernetes cluster. It was really fun. We made it work. It amazingly worked, just like a charm, until we forgot about it for like 2 months, and then the bill came in. It was exactly the same thing that Holly told, like just a few hours later. I got a bill for, it wasn't that bad, but it was just like a few €100 a month for nothing. People used it for two months, and then they haven't used it, but it's been €200 every month. Do you really want to pay that? So you kind of need to visualize and make all those things visual to the customer and see what they actually, if they don't care, that's fine. Then you need to talk about some other things. Do you want me to spend my time making that application scalable without it being useful? Or do you want to spend say, I don't know, 1,000 euros or 500 euros a month on a cluster that idles most of the time. Or maybe they have a really good use case for Kubernetes. Maybe you can actually do a Kubernetes and then install Knative on top of that and do like serverless thing and can actually share it between different applications and use that. Or just use Kubernetes for that, for sharing between different applications and everything. But then, it brings a lot of complexity, it brings a lot of networking, brings a lot of security, brings a lot of those things. Do they really want to spend time? You kind of say, well, you know what, making that application scalable in this way will cost you that much. Buying another server and scaling horizontally and satisfying all your needs will cost you 10 times less. Which one do you choose? I can do both. And then it depends on really on the case. I mean, it's not the answer you probably want to hear, but usually it depends. But try to see if there is actual use case for that and see if you can convince them. And usually it's like showing value is the way to convince in a positive way, to ask, to make them go over to something. You do it tiny little bit by tiny little bit, and then they see value and see a return of investment, and they want more and more and more. For the opposite, then maybe you need to kind of visualize the whole cost and say, hey, this is what it's going to cost you roughly, plus this management, plus if you're going to run Kubernetes on-prem without using a cloud, you have to have an ops team that will do all this because we need to handle certificates, we need to do the networking, we need to do someone, kicking a rack of servers when they're not working properly and just make them blink again, and all these kind of things. And it's like, and this and that, do you really want to do really all that? Or we should don't do that. Or maybe we should move to cloud and use managed Kubernetes servers, right? I hope it kind of answers you, at least points you in the right direction. And we can talk more about that. Any other questions, any other kind of frustration, like, anything? Because when I do this kind of talks that are not like heavily technical, I've been asked to keep it without too much of tech, without too much of a platform because of the track we're in. Usually people ask, like, how do I do something? I have this problem, how do I solve it? And this kind of thing. So it's okay to ask this kind of things. It's really fun actually to see. I mean, it's not fun to see the suffering, but it's fun to solve and help people. Anyone? No, I guess everybody is very ready for a party. Yeah. All right. Well, if there is anything, this is how you find me on social media. On Twitter, find me, ping me, and we can talk more. My DMs are open. So, thank you all for coming.